Okay, welcome to this video on everything you need to get a grade 6 to 9 in maths. There is an absolute ton of content in this. Do make sure you check out my video that I did previously that I've linked in the description on everything to get a grade 5. You do need to still have a solid understanding of all those topics, but here is a good accumulation of a lot of topics for your revision if you are aiming for those higher grades in your maths GCSE. Obviously, again, you do need to conduct your own subject analysis just to make sure that you do cover everything off, but there's tons here, so we're going to get started. Just make sure you like the video, share it with your friends, and obviously please subscribe to the channel. Okay, and obviously don't forget to follow me on Instagram and on Twitter as well. Okay, so kicking this off with fractional and negative indices. So you've just got to remember, looking at this one on the left, if there is an indice, the negative does the reciprocal, which I always just write as a flip. The bottom is the number underneath, which does the root. And then the number on the top is just a normal power. Okay, so I'm just going to put power with that, so normal power. So for this particular one, we've got all three going on. So I always start with flipping it over, doing the reciprocal, and remembering that 8 is just a number, so we could write that as 8 over 1. So when we flip that over, it becomes 1 over 8. Then we've got to do either the root or the power. I always like to do the root first, make the number smaller before trying to then do the power. So a 3 on the bottom would represent a cube root, so we need to do the cube root of both of these numbers. The cube root of 1 is 1. And the cube root of 8 is 2. 2 times 2 times 2 is 8, so it's 1/2. Then we've got to finish it off. We've still got to do that normal power there. If it was a 1, it wouldn't affect it, but a 2 as a normal power is squaring. So if we square them both, we get 1 over 4 as a final answer. And just remember to follow all those rules. Now looking at the one on the left, we've not got a negative, so we don't have to flip it over, but we have got a 2 on the bottom, which is the root again, and a 2 is a square root. And then we've got a 3 on the top, which is going to cube the numbers. So if I start with the roots to start with, if I do the square root of both of these, and it's always a little hint there, they are square numbers. The square root of 9 is 3, the square root of 100 is 10, and then we've got to actually cube them as well. So if I cube these as well, let's write that in. 3 cubed is 27, and 10 cubed is 1,000. So it'll be 27 over 1,000. I've just been very careful to get those right. So that's negative and fractional indices. Okay, so when you see this sort of question, you see these words here about bounds. There's always something we need to write down straight away. So we've been given two numbers here. So S is correct to 2 decimal places and T is correct to 1 decimal place. So the first thing I'm going to write down is the error intervals for them before I move any further. So writing our error interval, arrows pointing to the left, and an equal to symbol on our lower bound there. So I always start with the upper bound and I just stick a 5 on the end. So 8.24 with a 5 on the end, and then we just need to take that 5 off for the lower bound, so it'll be 8.2, not 4 but 3 with a 5 on the end, and then do the same for the other one as well. So let's write down the upper and lower bound for 3.5. So 3.5, stick a 5 on the end, and then for the lower one, 3. Drop it down to a 4, and again just stick a 5 on the end. Now this question here asks us to find the upper bound. So when it comes to a fraction, and you could have anything here, but when it comes to a fraction, if we want to get the biggest possible answer, we want to do either, we've got to decide here, either we're going to do the upper bound divided by the lower bound, or we're going to do the lower bound divided by the upper bound. And we've just got to think which one there is going to give us our biggest possible answer. And that is the upper bound divided by the lower bound. So we want the biggest number on top divided by the smallest number, and that'll give us our biggest possible answer. So we want the upper bound of S sitting on top, so the 8.245, and the lower bound of T, 3.45 sitting on the bottom. So this is a calculator question. So we just need to type that in the calculator, 8.245 divided by 3.45. and see what we get as our answer there. So if we type that in, 8.245 divided by 3.45, and we get the answer. It's quite a lot of decimals here, 2.3898557. Always just write down all the numbers and then round it however you've been asked in the question. This one says 3 decimal places, so let's chop it after the 9, and that would go to 2.3, and this is a bit of a dodgy one because the 8 rounds the 9 up, so it would go to 2.390, keeping the 0 in there. It does say 3 decimal places, so 2.390 would be my answer there. Okay, obviously it might say lower bound as well, in which case you'd use the other side of the formula, would you use this one instead. You might even be asked to do both of them and then round it depending on what they both look like. So if we imagine that the lower bound comes out as, and if we just make something up here, let's imagine the lower bound comes out as 2.295, 5 or something like that. Now it might say considering bounds give your answer to an appropriate degree of accuracy, and if you look at both these numbers, if we just imagine this is the lower bound, it's probably not, but if we imagine it was, these two numbers would not round the same to 2 decimal places, not to 3 decimal places, not even to 1 decimal place, because the one on the left there would round to 2.4 and the one on the right would round to 2.3. So if I did have to consider bounds to give an answer for this, I'd just have to say 2, and I would say the answer is 2, and that would be to 1 significant figure. So I could be asked that as well, and I just look at the upper and the lower bound and I round according to how they both actually round. And in this case, my little example here, they only round the same to 1 significant figure. Okay, so recurring decimals as fractions. So a little rule, we are going to use a bit of algebra for this, but if there's 2 recurring decimals, we're going to times it by 100, and if there's 1 recurring decimal, we times it by 10, and so on. There's lots of different ways of doing this. This is just the way that I do them. So I write what the decimal is. So we've got x equals 0.54. And remember, if there's a dot above the 5 and the 4, that means that decimal there is 0.5454, and continues like that. It's the 5-4 that's recurring. It's always good just to write that down, just to remind yourself what that decimal actually represents. So if we've got 2 recurring decimals, we can times that by 100. You'll see why if you've not seen this before. Hopefully it's just a reminder. You get 54.54. Now we can take them away from each other, and that'll eliminate these recurring decimals here. If we take them away from each other, we have 99 x's equals 54. And make sure that you actually do use your algebra to show this. Now we can divide both sides by 99, so x equals 54 over 99. And there it is as a fraction. You do just need to check just to see if your fraction simplifies, so do check to see if this one simplifies. This one actually does. The top and the bottom both divide by 9, and you'd normally be asked to show that it equals this next one, but if it doesn't, you know, you can look to simplify if it says to give it in its simplest form. And if you divide them both by 9, you get 6 over 11. So the question might have said show that it equals 6 over 11, and that's how you would show it. You'd show how it simplifies. Now on to the one below. It's only got 1 recurring decimal, but it's a bit of a nasty one. So if we think about what this decimal actually looks like, 0.23 with the dot above the 3, that's 0.2 and then a recurring set of 3s. It's not a full repeating pattern of 2, 3, 2, 3, 2, 3. So if we have a look at this one, and again there are different ways of doing this type of question here, but this is I just follow the same process for all of them. So x equals 0.23 with a dot above the 3, and there's 1 recurring decimal, so let's times it by 10. So we get 10x equals 2.33, and then the 3 keeps going. I'll just balance it out so there's the same amount of decimal places in both. Now if we take these away from each other, something kind of interesting happens here. We get 9x equals, and 2.33 take away 0.23 is 2.1. Now if we take the same approach as before and turn that into a fraction, so dividing both sides by 9, we get x equals 2.1 over 9. And obviously you can't have decimals in fractions, so we need to remove this decimal from the top, so we can times the top and bottom by 10, and that would give us 21 over 90. There you go, and there's your fraction. And again, you just need to check to make sure to see if that simplifies or not, and it actually does. The top and bottom both divide by 3, so you can divide the top and bottom by 3, and you would get 7 over 30 again. So it might have said show that this fraction equals 7 over 30, but always just check at the end to see if it simplifies. Obviously if it just said to write it as a fraction, 21 over 90 would be fine, but if it said to give it its simplest form, we would have to look to simplify there. Okay, so some compound interest. James invests £2,500 for 3 years in a savings account and gets 3% per annum compound interest in the first year, and then X% for 2 years. He has this much at the end of the 3 years. Work out the value of X. Well, just like normal compound interest here, we can actually do the first year. So we can work out, I'm just going to label this up. So after the first year, let's see how much money he has. So 2,500 for 3%, we would times that by 1.03. Obviously we don't need to add any powers into there because it is just the first year that he's getting this. So if we do this on the calculator times 1.03, and we get an answer of £2,575. Now we've got a bit of a reverse compound interest scenario, and we're going to have to create a little formula for this, because in the second and third year he gets X%. Now his starting number, and let's just write down second and third, his starting number now is 2,575. Now if we knew the percentage, we'd multiply it by that percentage, which we'll call x in this scenario because we don't know what it is, and we'd do that to the power of 2 as it's 2 years. And what it's saying in the question is that gives us the answer £2,705.36. Now obviously at this point here we could just guess some numbers, we could just guess an x value, and if it's too high go lower, if it's too low go higher, and that's a fine way of doing it as well, but you can save yourself a bit of time here just guessing lots of numbers by actually just rearranging this. So we can divide both sides by 2575 and it will give us the value of x squared. So x squared is going to equal, and again let's just do this on the calculator, 270536 divided by that gives us this answer here, 1.050625243. Now that's obviously the value of x squared, so we need to square root both sides. So if we square root that answer, we get the answer 1.025000118. So that gives us our little percentage here. So it's hidden within this decimal. Now our actual percentage here is not 1.025 because that 1 point is what we increase by for the percentage. So it's just this 0.25 that we're interested in, and 0.25, if you think back to what we did at the start here with 0.3 being 3%, well 0.25 would be 2.5%. There we go, so that's 2.5%, so just be careful that you do read that off there and don't put 1.025 in this type of question. But again, you could have guessed, if you'd have guessed 1.02, it's normally going to be lower than that first one. That's normally what banks do, they give you a better one in the first year and then not so good following that. Okay, so there's just two ways that you can approach that. You can guess some numbers, or you could obviously just rearrange it and find it there. Just being very careful that you actually read the percentage from that 1 point number. Okay, so we've got some Surds questions. So 3 plus root 5 squared in the form a plus b root 5, where a and b are integers. Okay, so we need to have a look at this. So that obviously is a double bracket there. So if I rewrite this as a double bracket, we've got 3 plus root 5 and 3 plus root 5. And we just need to expand that now and see what we get. So lots of little Surd rules going on in this one. So 3 times 3 gives us 9. 3 times root 5 is 3 root 5. Root 5 times 3 is another 3 root 5, and then root 5 times root 5 is root 25, and it just becomes 5. Remembering similar Surds, exact same Surds, when you multiply them together become the whole number. And if we simplify all this down, 9 and 5 makes 14, and then we can add together these Surds in the middle because they both have a root 5, so we've got 3 lots of root 5 and 3 lots of root 5, which is 6 lots of root 5. And there's your answer just there. So A would be 14 and B would be 6, and that is in the form a plus b root 5. And there's our answer with a bit of Surds. Let's have a look at another Surds question. Okay, so we've got to show that this can be written in this form. Now when we've got Surds on the bottom of a fraction, we're always going to look to rationalise it. Now with some of the easier Surds, you just times the top and bottom by whatever this root is just here, so by root 3. Unfortunately that's not going to work for this one because we've got 2 plus root 3, and if we did times the bottom by root 3 there, we'd get 2 root 3 plus 3, and we'd still have a Surd on the bottom. So what you do when you've got this on the bottom is you times it by the denominator still, but we change this little sign here. So whatever that sign is, we're going to flip it to the opposite. So we're going to times it by 2 minus root 3. So always write that down, okay, because you do get marks for these elements of your working out. So I'm just going to rewrite the fraction 2 plus root 3, and I'm going to show next to it what I'm timesing the top and bottom by. So I'm going to times by 2 minus root 3, and I'll put that in a bracket because I'm going to do a double bracket here, and I'm also going to times the top by 2 minus root 3 because we're creating an equivalent fraction here. So it's up to you if you want to put these in brackets as well, just to remind yourself you're doing a double bracket, and then you just need to multiply both of them out and see what we get. So on the top, and I'm not going to draw all over it, I'm going to times them both by the 5 first, and then times them both by the 2 root 3. So 5 times 2 on the top gives us 10. 5 times negative root 3 gives us negative 5 root 3. Onto the 2 root 3, so 2 root 3 times 2 is positive 4 root 3, and then 2 root 3 times negative root 3, and this is the multiplication you always just got to be careful of, gives you 2, I'm going to do it to the side, we get 2 lots of root 9. 2 lots of root 9 is 2 times 3, which is 6, so that number at the end there, and careful because one's positive, one's negative, so we get negative 6. I'll tidy that all up in a sec. Let's have a look at what's on the bottom. Now the whole reason we're doing this on the bottom is to eliminate the Surds in the middle. So you can do a bit of a trick when you're doing these. You can just do the first 2, which is 2 times 2, which is 4, and the last 2. So root 3 times root 3 is 3, and it's minus 3. There we go, so that's why our fraction's disappearing, because it's 4 minus 3 on the bottom. Let's tidy up what's on the top. So on the top there we have 6 and the 10, so we've got 10 minus 6, which is 4. We've got negative, let's do this in a different colour, we've got negative 5 root 3 add 4 root 3. Negative 5 add 4 is negative 1, so minus 1 root 3 or minus root 3. And that's all over 4 take away 3, so it's over 1. So when we're dividing by 1, we can get rid of the fraction there, and we get 4 minus root 3. So there's some surd elements to be thinking about. Obviously there are so many different questions on surds that you could actually have, but there's a couple of things there to be thinking about. The other thing is obviously to remember that surds can only be collected together, like in here, when the number underneath the surd is the same. Okay, so you will have to know how to simplify surds as well, but I've got plenty of videos on that to check out. Okay, so we've got some standard forms, we've got some multiplication and some division. I'm going to start with this multiplication. Now I'm primarily thinking this is like a non-calculator style question, because obviously if this was on a calculator you could just type it in nice and easy and write it in standard form. So actually we're going to have to do a bit of a trick here. So 3.2, I can times that by 4 to figure out what my starting numbers would be. So 3.2 times 4, again, you've just got to work that out, whatever method you're used to using. I'm going to do 32 times 4 and hop the decimal back in. So 4 times 2 is 8, and 3 times 4 is 12, and then hop the decimal back in, so it's 12.8. So the answer I get there is 12.8. It's going to be times by 10, and when we're multiplying we can add together the powers here, so 3 plus 4 gives us 7. Obviously though it says to write your answer in standard form, and that number here, 12.8, is not between 1 and 10, so if I hop the decimal in, making the number one place value smaller, I'd get 1.28, and if I make the number smaller, I have to make the power 1 bigger, so it'd be 10 to the power of 8. Okay, so don't be put off by these sorts of questions. Do your multiplication, follow your power rules, and then balance it out. Just remember, if you make the number smaller, you make the power bigger. We'll take this exactly the same approach for this one, except it's a divide. So I need to do 3.6 divided by 4. And again, it's up to you. You can hop the decimal out and hop it back in, but I'm just going to do 3.6 divided by 4 using a bit of bus stop. So 4 doesn't go into 3. So carry the 3, and then 4 goes into 36 9 times. There we go, so it's 0.9. So when we divide that, we get 0.9 times 10 to the power of, and when we're dividing, we can subtract the powers. So the first power there is 2, the second power is negative 3. So just write that down to the side. What have we got? We've got 2 take away negative 3, which is 2 add 3, which gives us a power of 5. There we go, so the power is 5. And then again, we just need to balance that out because obviously this is not between 1 and 10. So I'm going to hop the decimal this way, making it 9. So this time I've made the number bigger. So I need to make the power smaller, so it goes down to a 4. And there's our final answer, 9 times 10 to the 4. And the last question on this section. So we've got in 2008, Alice bought a house in 2008 Alice bought a house. In 2014 she sold it for 20% profit, and in 2019 it was sold at a 5% loss, and it gives us the value that she sold it for. Work out the cost of the house in 2008, so right back at the start. So we had 2008 she bought a house and she sold it for a 20% profit. Then in 2014 it was sold for a 5% loss. And then in 2019 the value of it was 182,400. Right, so at this point in 2019, this cost here to whoever she sold the house to in 2014, this was sold at a 5% loss. So to her, that was only 95% of the value that she bought it for. So if we've got a calculator here, in order to turn that back into 100%, quite nice and simply, we can divide it by 95 to get 1%. So if that there is 95%, we can divide that by 95. So divide by 95, which would give us 1%. So 1% would equal, and we'll just do this on the calculator, 182,400 divided by 95 gives us 1,920. And then to get back to 100%, we just times that by 100. So we can just add 2 zeros on for that. So 1920 with an extra 2 zeros. There we go, so 192,000. So that's the price that it was sold for. That she paid for it before. So before that, it was 192,000. That's not a zero. 192,000. And then we've got to think about the original sale in the first place. So that means that 192,000 there was at a 20% profit. So if that was a profit to Alice in the first place, then to her this amount of money was 120%. Okay, it was 20% more than she originally paid for it. So we can follow exactly the same approach now. If that's 120%, we would divide that by 120 to give us 1%. So 1% here would equal, and we'll just work that out, divide that by 120, and 1% is 1,600. And again, you can times that by 100 to get 100%, and our original cost up here would be 1,600, with 2 zeros on the end, so £160,000. There we go, so 160,000. There we go. So that's it using a calculator. That's moving through two reverse percentages there, one with a decrease, one with an increase. You just got to remember, if something's been decreased, then we get this 95%, whatever was left over. And then there was also the scenario where at one point it was increased, making it 120%, that extra 20% there. So this can be done calculator and it can be done non-calculator. The 95% one wouldn't be very nice, but thinking about how you could have done this 120%, which is quite common when VAT is added on, because they often have these VAT questions where they say VAT was added on at 20%. There is a way of doing that without a calculator, and what you could do when that happens is you can divide by 12 and then times by 10. So you could do that without a calculator. You could do a bit of bus stop there and divide 192,000 by 12 and then just add on a 0 when you times by 10. Okay, there we go. Okay, and on to algebra. This is a bit of a long one. Let's have a look. So we've got triple brackets to start with. Now you can expand any two that you want to start with. I'm just going to go for the first two. So if we expand those to start with, let's have a look at what we get. So 2x plus 3 multiplied by x plus 4. Now if we expand that out, just following normal expansion rules, we get 2x squared plus 8x plus 3x plus 12 on that last bit there. Okay, tidying that up first. So tidy this up, simplify it down, we get 2x squared plus 11x plus 12. Now we can multiply it by the final bracket being up there, the 3x minus 1. So stick this in a bracket and multiply it by 3x minus 1. Again, just take your time with this, it does get quite messy when you're doing it. Okay, so just spend the time, make sure that you get each piece perfect. So let's move this out of the way. And let's just be really, really careful when we expand this now. So 2x squared times 3x gives you 6x cubed. And then 2x squared times minus 1 is minus 2x squared. Onto the 11x. Let's go for a different colour. So 11x times 3x is 33x, so positive 33x squared again. There we go. And then 11x times negative 1 is a negative 11x. Two more to finish this off. 12 times 3x is 36x. Just about fit this in. And then 12 times minus 1 is minus 12. Right, there we go. We just need to tidy all this up now because we've got a lot of pieces there. We've got the 6x cubed at the start. We've got negative 2x squared add 33x squared, so negative 2 add 33 is 31, so plus 31x squared. Negative 11 add 36 is 25, so 25x squared, sorry 25x, and then the minus 12 at the end. And then do just go back, double check, make sure you've added up the pieces correctly, just to make sure that you don't make any mistakes on that final part there. But that's expanding a triple bracket. Just remember to tidy up your first double bracket and then multiply it very carefully by the next one. Okay, so factorising a quadratic, and here we've got a coefficient bigger than 1 at the start. So we just need to have a think about how you do this. You can have 2, 3, 5, you can have any combination of numbers here. But in order to get a 2 at the start there, we're going to need 2x in one of our brackets, and then x in the other. And then we'll just follow the same process, write down the factors of 12, so 1 and 12, 2 and 6, 3 and 4. And we've just got to think, okay, well, one of these numbers is going to double and we want to make negative 5. Obviously, this one has a negative 12 at the end, so one's going to be positive, one's going to be negative. And when one doubles, we're trying to make that number 5 in the middle. So it's not going to be 1 and 12, because we can't make 5, particularly if we double the 12. We're not going to make 5 if we've got a 24 and 1. And we're not going to make 5 out of 2 and 12, so it's not that one. Let's have a look at the next one. Doubling the 2 would make 4, so 4 and 6. Can't make 5 out of 4 and 6. Doubling the 6 would make 12, and you can't make 5 out of 2 and 12, so that's not going to work either. Let's try the 3 and 4. Double the 3 would be 6. We can't make 5 out of 6 and 4, so it's going to have to be this last one. Doubling the 4, which is going to make 8, so 3 and 8, and that works. You could do positive 3, take away 8, that would give us negative 5. So we want the 4 to double, so we stick that in the opposite bracket to the 2x. We want that one to be negative, so stick a negative with that. And stick your plus 3 in the other one, and there is your factorised double brackets. Just remember as well, it could say actually to solve something like this, and you can solve by factoring. If it did say the word solve, then we'd have two solutions here. For this right bracket, it's nice and easy, just flip the sign, we'd have x equals 4. And for this left bracket here, nice and easy again. It's still flip the sign, still 3, but because of this 2x here, it'd be minus 3 over 2, or minus 1.5. So if it did say solve, that'd be an additional step that you could go about. You could say x is negative 1.5 and x is 4. Okay. Okay, so we've got rearranging or making x a subject here, and we've got 2 x's in our formula. So, I mean, we can have so many combinations of this question that you can have. The whole idea of this type of question, though, is that you get the x's on the same side of the equal sign, everything else to the other side. Now, obviously, the x's are on the same side of the equal sign at the moment, but we want to get rid of this fraction. So you might not have a square root in a question, but in order to get rid of this square root to start with, we need to square both sides. So if we square both sides, we get y squared equals, and then what's left under the square root, it's not going to change that, we're just going to have x plus 3 over x minus p. Now again, we've still got a fraction involved, so we need to get rid of this denominator. So whatever's on the bottom there, we're just going to times both sides by what's on the bottom. I'm going to stick it in a bracket because it's easier for me to move it. So x minus p, and times the other side by x minus p. Okay, so we've got a bracket on the left, we've got y squared, brackets x minus p, equals x plus 3. Now, as soon as we've got rid of this bracket, we can start to actually move the pieces out of it. So if we expand the bracket, we get y squared x minus y squared p, or py squared, however you want to write it, and that equals x plus 3. Now I can start to move the pieces either side. So let's go for, there's two ways of doing this one. At the moment, I could move the x's to the left or the x's to the right. Now what I'm going to do is I'm going to move the x's to the left, so I can get rid of this negative y squared p, or plus py squared. I'm going to rewrite it differently. So plus py squared to both sides. Let's bring this up here, and we get y squared x, or xy squared. I probably should have rewritten it there, it doesn't really matter. Add they over, so we get x plus 3 plus this new py squared over here. Now we can minus the x from both sides. We can get all our x's on the left, so minus x. So, and again, I will write this now. I'm going to write xy squared, I just prefer it. Xy squared minus x equals 3 plus py squared. And here's where this process starts to come in now. We can factorise this left-hand side so that we get 1x. So we'll get x brackets y squared minus 1. That equals 3 plus py squared. And then you can divide by this bracket here and slot it underneath the right-hand side. So you get x equals 3 plus py squared over y squared minus 1. And there would be our final answer. Obviously there is an unlimited amount of different formulas that you could have to rearrange. So I'm only going to go over the one here because it involved a lot of different steps there. Getting rid of a square root by squaring, getting rid of a denominator by timesing it across, putting it in a bracket in this second step. That was over here. And then we had obviously expanding a bracket, getting all the x's on the same side, factorising it to finish. I mean, you've got literally every possible step you could think of in this one. So it's quite a difficult one there, but there's just an example of some rearranging and what to do when there's two subjects that you're trying to turn into the one. Okay, so working out the nth term for this sequence. So whenever you're working out the nth term of a sequence, this is a quadratic one. It doesn't say it in the question, but it is a quadratic. You hopefully can see that just by looking at it, because here it goes up by 4, and here it goes up by 6, and then here it goes up by 8. Okay, so because of that, we've got a second difference here. So the second difference is 2. Now, whenever you get a second difference, what you need to do is actually divide that second difference by 2. It's just something which happens with the square numbers. If you think about the square numbers, and this is why it's a quadratic sequence, 1, 4, 9, 16, the second difference comes out as 2. Let's have a look. So 3, 5, 7. And the second difference is 2, and that tells you that it's related to the square numbers, but it can be more than just the square, like one lot of the square numbers. So if we divide this by 2, it tells us it's 1n squared, or it's related to the square number sequence, which is this one here, n squared equals 1, 4, 9, 16. So what I always do is write down the square numbers now. Again, I know there are formulas for this, but I just really prefer this method. So 1, 4, 9, 16. But now if you have a look, there is actually a difference between the n squared sequence and the one going up there in the question. To get from 1 to 15, let's just write this down. What's the difference? To get from 1 to 15, that's plus 14. To get from 4 to 19, that's plus 15. And to get from 9 up to 25, that's plus 16. And this just carries on. Look, from 16 to 33 is plus 17. So not very nice. Look, if we had a constant difference, if they are all plus 14, then you'd just put n squared plus 14. But unfortunately they're not, so we can't do that. They're not all just plus 14. So when you get this scenario here, you've got to have a look at this sequence and think, okay, well I'm going to have to just work out the nth term of that sequence. And the nth term of that sequence is, it goes up in ones. Look, 14, 15, 16, 17, it goes up in ones, so 1n, or n. And then it's obviously not the 1 times table, or if you know the little trick where you go back here, you take away 1, you'd get a 13 at the start. So it'd be plus 13, because it's 13 bigger than the 1 times table. So that sequence there has an nth term of n plus 13. So all you do is you just slot that at the end of n squared, so n squared plus n plus 13, and that would be your nth term of this quadratic sequence here. Okay, n squared plus n plus 13. You can get something slightly different here, like if you had a second difference of, if we just imagine this to the side, if you had a second difference of 4, so if it was 4, your sequence would start with 2n squared. And then you would have to write out double the square numbers. So instead of writing 1, 4, 9, 16, you would write 2, oh, what happened there? You would write 2, 8, 18, 32, and then you would compare the difference back to these numbers. Similarly, if it was 3n squared, if there was a second difference of 6, you would triple all the square numbers and compare it again. Obviously, just remember, if this comes out as a constant difference down here, that's great, you can just put that after the n squared part, or the 2n squared, but if it is a new sequence, you are going to have to forget about the rest of the question for a second and just work out the nth term of that sequence, and then slot that on the end. So our final answer there, n squared plus n plus 13. Okay, so this question says find the coordinates for the turning point of the graph with this equation. So to find the turning point, we have to do something called completing the square. And sometimes it might say write it in the form. It might say x plus a squared plus b. It might say write it in that form. Okay, and that just means completing the square, and it's how we find the turning point. So in order to do this, you have a look at the x coefficient, which is there, and we halve that number, and we stick it in the start of our bracket like this. So we have x plus 8 halved is 4 squared. And the reason you do that is because if we expand this bracket, and if we think about it to the side, if we expand that bracket there, x plus 4, x plus 4, x plus 4, there we go, we would get x squared plus 4x, which would give us 8x, but we would get plus 16 at the end. So obviously it's similar to this part just here. We've still got the x squared, we've still got the 8x, but we've got plus 16. And we don't want plus 16, we want plus 3, because all we're doing is we're rewriting it as in a different form, in this completed square form. So in order to make sure 16 becomes 3, we would have to subtract 13 from this double bracket there. 16 take away 13 give us 3. So that is actually written in completed square form there, and that is how you do it. Now you don't have to fully expand the double bracket. You can just think, okay, well 4 times 4 is 16. That's the number I know I'm going to get at the end. So I'm going to have to take away 13. And our coordinates for the turning point are written within this. So the x coordinates in the bracket there, just like when you're solving, you flip the sign. So the x coordinate is -4 instead of +4. And the y coordinate here is just this number at the end. No flipping of the sign, just writing whatever's there, so -13. There you go, so the coordinate of our turning point is -4 and -13 for the y coordinate. And that's completing the square. Okay, a longer question here, we've got to solve the simultaneous equations. Now when we've got an x squared and a y squared, this actually represents the equation of a circle and the equation of a line. Okay, and that line would be, go sloping this way I believe, let's have a look. Okay, so when you get this sort of scenario here, you get two solutions because there's two crossover points. There is one scenario where you might get one solution, which is where it's a tangent to the circle if it just touches at one point. There could even be no solutions, but it would be unlikely we'd be asked to try and solve something with no solutions. So if we have a look at this, we've just got to basically sub one into the other, and we can sub this x minus y equals 2 into the equation of above. So if we actually do that, first of all we've got to rearrange it. Now there's two ways. I could make y the subject or x the subject. So I'm going to make y the subject, so I'm going to add y to both sides, which actually that would straight away make x the subject, so let's do that. X equals 2 plus y. Okay, you could even write that as y plus 2 if you prefer, and I'm actually going to do that, x equals y plus 2. Now what we can do is we can sub this little expression here, y plus 2, in place of the x in the first equation, this x squared. So if I just do that, so rather than writing x, I'm going to write y plus 2. So y plus 2 squared plus y squared equals 34. Right, so we've now got an equation that has no x's in, and we know that when we've got an equation that only has one unknown in it, we can definitely solve it. So if we actually go about expanding this first bracket here, I'm not going to write it as a double bracket, I'm just going to go for it. So y squared, we'll get plus 2y, so plus 4y, and plus 4 at the end. And then obviously we've got plus y squared equals 34. Now we can tidy that up, look, because we've got these two y squared pieces. So we can add those together just to make it a bit more tidy. So we've got 2y squared plus 4y plus 4 equals 34. And now we can only actually solve one of these. It's a quadratic, so we can only solve that once it equals 0 at the end, so we need to minus 34 from both sides. So if we minus 34, we get 2y squared plus 4y, and 4 minus 34 is minus 30, and that now equals 0. So we can actually go about solving this now. Now, if in this point here, if we've got a calculator, we could potentially use the quadratic formula, we could factorise it from here, but if you notice that all these numbers here all divide by something, we can simplify it down, because we can divide both sides by anything as the right hand side is just 0, it doesn't change it. So if we divide everything by 2, we get y squared plus 2y minus 15 equals 0, and it potentially just makes it a little bit easier to factorise there. Now if we go about actually factorising this, both are going to have a y in. And we're just thinking what numbers there multiply to make 15. So we've got 3 and 5, or 1 and 15. I'm not going to write down the 1 and 15 because I've already spotted it's 3 and 5. And in order to make 2, we need plus 5 minus 3, and that's going to give us positive 2 in the middle. So we've got two solutions going on here. Obviously it's just these numbers in the brackets, but flip the symbols. So we've got y equals negative 5. And we've also got y, I'm just about to write x there, y equals 3. So there's our two y solutions. We now just need to find our x solutions. Now we've got a nice little formula that we made right at the start here. To find x, we've got x equals y plus 2. So when y is 5, x will equal negative 5 add 2, which is negative 3. So x equals negative 3. And then for the next one, we've got y equals 3, so x equals 3 plus 2, so x equals 5. There you go, so you've got your two solutions and they're written in pairs there. We've got our first solution here, x equals negative 3, y equals negative 5. And we've got our second solution over here, x equals 5 and y equals 3. Okay, so there would be coordinates there. So it might be, if we think back to this graph, it might be that this coordinate where it crosses over is negative 3, negative 5. And this coordinate up here is 3, 5. Okay, so that's what it represents there when we're solving these simultaneous equations. And remember, that could be solved graphically as well. You might be given a diagram, drawing on a straight line and then just, estimating them or finding them exactly where they cross over. Okay, so there's solving simultaneous equations, and again, there's loads of different variants here. You might have two that have y squared in or y in, and you can set them equal to each other, but this is just one of the harder ones here where you've got to sub one into the other. Okay, so we've got some quadratic inequalities. So we're going to solve this. Now obviously these represent a parabola, a curve, a quadratic graph. Again, a quadratic graph here. Normally when we're solving them, we are solving to find these two roots here, or solutions, and you can be asked to to find them or to estimate them from a graph. If you've been given a picture, they're referred to as the roots. But when we're solving an inequality, we're looking at something slightly different. Now this first one here, and they're both exactly the same. We're going to have a look at the two different scenarios. This first one says less than 0. So essentially it's saying is what part of this curve is less than 0. Now if you have a look, this part of the curve is what's below ground, what I like to refer to, or less than 0, 0 being the x-axis there. So really all we're going to say is, well, what part of the curve is between these 2 points below 0? So if we actually just factorise this to find out what these two roots are, so putting it into a double bracket, again it might have a coefficient bigger than 0, but I'm just going for a nice easy one here just to show you the process. So the factors are 24, we can have 4 and 6, 2 and 12, 3 and 8, so I'm just going to not write them all down because I've already spotted it's 3 and 8. But that would be plus 3 minus 8, and that would give us minus 5. So our roots here, our solutions are x is negative 3 and x equals 8. So if we were to label those on the graph here, this would be minus 3 on the x-axis and this would be 8. Now the bit that is below the curve is between negative 3 and 8. So I'd have to write this as one of these types of inequalities. Okay, where we say it's between 2 points. And that would be my answer there. X is between -3 and 8, or the part of the graph that is under 0 or less than 0 is between those two numbers. Now that would change slightly for this one down the bottom, because I've just realised they're pointing the same way. That wasn't meant to be pointing that way. Let's change that. That's meant to say bigger than 0. Okay, so there we go. Sorry about that. Let's change that. X squared minus 5x minus 24 is bigger than 0. So this would be something slightly different now, because the bit that's bigger than 0, and if I just redraw this graph, there we go, 8 here, -3 here. The bit that's actually bigger than 0, we've got one part over here, and we've got a completely separate part over here. So we've got two separate parts of the line, and that means I can only write this as two separate inequalities. Now this part on the left is all this part of the curve is going to numbers less than 3. So my solutions there would be, well, anything that's less than 3. Sorry, -3. So x is less than -3. And that's one of my solutions for that part of the line. But I've also got the other part, and that is going to all the numbers bigger than 8. It's going this way. So my other solution would be x has also got to be bigger than 8. So I've got two solutions here to write with my inequalities. I've got all the x values less than -3 and all the x values bigger than 8. So that's solving a quadratic inequality. Just got to think about which part of the graph you're actually looking at. Okay, and we've got a question here that's shade the region that satisfies all of these inequalities, and we've got these three inequalities there. Now some of these are quite easy to draw, but when we're drawing these inequalities, if we just imagine us to start with that the inequality is an equal sign, it's just going to help us to actually draw the graph. So all I'm going to do is I'm just going to imagine that this one says y equals 2x plus 1. I'm going to draw that line. X plus y equals 4. I'm going to draw that line, and I'm going to draw the line y equals 1. Now the easiest one for us to draw there is y equals 1. Now looking at my graph here, you can't see the number 1, but it's between 0 and 2. Now on the y-axis, y equals 1 is at this point here, and that line y equals 1 is just a nice straight line going through y equals 1. So that's our first one drawn there. Done. The next one is x plus y equals 4. I'm going upwards now, so x plus y equals 4. Well, if x plus y equals 4, that's quite a nice line to draw, because that means when one coordinate's 0, the other has to be 4. So 0 on the x-axis gives us 4 on the y-axis, and 0 on the y-axis gives us 4 on the x-axis. So you've got a nice diagonal line there to draw between 4 on both the axes, and these x plus y equals a number always just connects up the y-axis and the x-axis to those numbers. So we've just got to do a nice neat diagonal going through with a ruler and a pencil, and I'll continue that all the way. Oh, that's not very good. I'll continue that all the way to the top of the graph there, just a nice diagonal going all the way through. So that's that one done. And the next one there is y equals 2x plus 1. Now you might know little tricks for how to plot these. If not, then I would suggest just drawing yourself a little table and picking some of the values. You probably get away with doing 2 or 3 values. But if we sub in some x values to find our y coordinates here, when x is 0, that would be 2 lots of 0, add 1, y is 1. So if I do this in a different colour, so when x is 0, y is 1, that gives us that coordinate there. Let's pick 2 or 3, let's just go a little bit higher. So when x is 2, 2 times 2 is 4, plus 1 is 5. So when x is 2, y is 5, and that is here. And we could go for some negative numbers as well now, but hopefully you can get a ruler and a pencil and join those up. Now it has a gradient of 2, so I can just look at that coordinate on the y-axis there and go across 1 up 2, which gives us that coordinate there. Cross 1 up 2 gives us the one we've already drawn, and I can follow that pattern backwards as well. But you can draw a full table out for this just to make sure you get it perfect. But there we go, there's my line. I just need to connect those all together nice and carefully with a ruler and a pencil. And there's our 3 lines drawn. Okay, now it says shade the region that satisfies all these inequalities. Now careful, because it's not always that little triangle there that's made in the middle. So I'm going to get rid of these equations now, so I don't need them anymore. But I need to have a look at the inequalities. Now all I need to do is pick a coordinate and test it in these inequalities. So if we do pick this one in the triangle here, so this coordinate here, let's do it in a different colour. There's a coordinate inside the little triangle in the middle, which is the coordinate 1, 2. This coordinate here, well, x is 1 and y is 2. And if I sub them into these inequalities, as long as they all work, then that's the region I'm going to shade. So if I sub it into that first one there, x is 1 and y is 2, so y is, which is 2, is less than 2 lots of 1, which is 2, plus 1, so 2 is less than 3, and that works, that's correct. Moving on to the next one then, that one works, we've got to test all 3 though. X plus y is bigger than 4, so x is 1, so 1 plus y, 1 plus 2 is bigger than 4. No, that doesn't work. So it can't be inside that triangle there. Although what we have figured out is that the first one works. So in terms of that line, y is less than 2x plus 1 is my pinky red coloured line there. So it's got to be on the right hand side of that. So it can't be this region on the left, it can't be this region on the left, and it can't be this region on the left. So it's got to be one of the other four. But it's not inside that triangle now, so we can put a cross in there as well. We know it's not that one. So we've got 3 left to have a look at. So if we get rid of this, and obviously always leave your working out down, but let's try another coordinate. So let's try one in this region here, as this one's on the top. So that coordinate there is the coordinate 4, 3. Okay, so this one here, 4 and 3. And if we test those out into all our inequalities and see if they actually work. So looking at the first one, we've got y is 3, so 3 is less than 2 lots of x, so 2 lots of 4, 8 plus 1. So 3 is less than 9, and that's correct, that works. Moving on to this x plus y is bigger than 4, so x is 3, so 3 plus 4 is bigger than 4. Well, that's absolutely correct. 7 is definitely bigger than 4, so it works in that one as well. And then on to the last one here, y is bigger than 3. Sorry, y is bigger than 1. The value of y is 3 there on that coordinate, so 3 is bigger than 1. Perfect, they all work. So it's got to be that region there. So we just have to shade this region in. It might say to label it R or something like that, but shade it in and there's your region done. So once you've drawn your lines, just pick a coordinate, test it out into your inequalities, and as long as they all work and they're all correct, then you can shade that region. But do be careful you don't just shade the region of the shape there, like the triangle in the middle, because it's very often not just the shape that's formed. Okay, so we've got solving a quadratic here, and it says give your answer correct to 3 significant figures. Now this gives you a massive hint here, 3 significant figures, that it doesn't factorise. And when a quadratic doesn't factorise, when we've got to solve it, in whatever scenario, we've got to use the quadratic formula. So one that you need to remember, you've got minus b, plus and minus the square root of b squared minus 4ac, all over 2a. And then what I do straight away is I write down the values of a, b and c. So a is 5, the one in front of x squared. So a equals 5. We've got b equals, and you've got to be careful because you've got to get the symbols in, the signs in with it, negative 11. So b is negative 11. And c is, again, that number at the end, negative 13. So first things first, we just need to put them all in the right place. So minus b will be, well, negative b. B is already negative, so that becomes positive. So b is 11. Plus and minus the square root of b squared, and we're squaring a number here, and it's negative, so stick it in a bracket. Minus 11 squared, take away 4 times 5 times negative 13, 4 times a times c. So 4 times 5 times negative 13. There we go, and you can stick that all in a bracket if you want, just depends on what calculator you're using. And that's all over 2a, which is 2 times 5, which is 10. Let's just write 2 times 5. Now if you've got a Casio calculator, which hopefully you do because they are the best ones for these higher GCSEs, then you need to just type that in as you see it. So press your fraction button, 11. Let's do plus. I'm going to do the plus version first. So I'm just going to do it once using the plus sign here, and then I'll do it again in a different colour using the negative. So 11 plus the square root of, in brackets, minus 11 close brackets squared, take away, in brackets, 4 times 5 times negative 13. Go on to the bottom of the fraction, and I'm just going to type in 10. And when I type that in, turn it back into a decimal, it says I get 1 which is 3.05192213. And then I'm just going to go back into my calculator, change the plus sign for the minus sign, and we'll write down what we get there. So back into the calculator. Takes a bit of a while to get all the way back through this, but it's better than typing it all back in again. Delete the plus, put a minus, press equals again, and I get the answer negative 0.8519221296. There we go, lots of digits there. So obviously there are 2 solutions, one with a positive there, one with a negative. Then we've just got to round it, so it says 3 significant figures. So in the first one there, 3, 0 and 5 are my first 3 significant figures. So that would be 3.05 for my first solution. And the second one's a little bit iffy here because we've got a 0 at the start, so it's 1, 2, 3 after the 1. So that would be 0.852 because it's a 9 after it. There you go, and there's my 2 solutions written to 3 significant figures. Just be very, very careful when you're doing the quadratic formula that you do make sure of a couple of things. That is one, when b is negative, make sure it flips this sign for the first one, and the second one is make sure you put these negative numbers in a bracket. Otherwise, it's gonna give you an answer of negative 121 there rather than the positive 121. Although if you are squaring a negative number, you could just put 11 squared and forget about the negative, but a little bit of a trick there. Okay, there we go. On to the next one. Whenever we get an algebraic fraction, though, we just need to factorise everything that we see, no matter what the question, whether you're times and dividing, it's just simplifying, just factorise everything. And that can be quadratics with coefficients bigger than 1, we can have difference of 2 squares, we can have single brackets, but just look and see what can I do to factorise it. So the top there, there's no number at the end, so it definitely doesn't go into a double bracket, but the top, the 3x squared and the 9x both divide by 3 and they both have an x in, so we can simplify it, we can factorise it that way. So 3x times x gives us a 3x squared, and 3x times 3 gives us that 9x there. So that's that factorised on the top. Now if we have a look at the bottom, that has a number at the end but no x pieces in the middle, so that's a difference of 2 squares. The factors are 9, it's the 3 and 3, one positive, one negative, that's what cancels it out. So we have x plus 3 and x minus 3. There we go, and when we've got these common brackets on the top and bottom, we can cancel them out. So the x plus 3 and the x plus 3, we can divide the top and bottom by x plus 3. So we end up with a final answer of 3x over x minus 3. And again, you can have lots of different scenarios where you're simplifying an algebraic fraction. Again, there could be different sorts of quadratics or just single bracket factorising that you're doing. But there is the idea of how you simplify these. And no matter what question you see an algebraic fraction, you're normally always looking to factorise. Let's have a look at one more. Okay, so we've got some more algebraic fractions here. Now we're adding these together, so we need a common denominator. So I've got to solve an equation here, but I've got to get these algebraic fractions added together first before I can do that. So if we times both sides, or this left-hand fraction, top and bottom, by x plus 1, and also times the top by x plus 1, that's going to allow me to get a common denominator as long as I times the right by the left denominator as well, which is 3x minus 2, just following normal fraction rules there. So times that by 3x minus 2. Okay, and I've written that next to the top and bottom so I don't forget what I'm timesing by. So on the top there we get 8 lots of x plus 1, and we're going to add to that 6 lots of 3x minus 2. Now because I'm going to get a common denominator here, I'm just going to write that all over my double bracket, which is x plus 1 and 3x minus 2. There we go. Now we can go about expanding all of that and just get it all tidied up. So if I expand the top, we get 8x plus 8. And then we get plus 18x minus 12. And that's going to be all over this double bracket expanded. So x times 3x is 3x squared. I'm going to skip a step here. I'm going to do the minus 2x plus the 3x. Minus 2 plus 3 gives me plus x. And then minus 2 at the end. There we go, that all equals 2. Before I set it equal to 2, I'm just going to tidy up what's on the top there. We've got 8x and 18x, which is 26x. And plus 8 minus 12, which is minus 4. And that's all over 3x squared plus x minus 2. So now I've got a single fraction with a common denominator, and that equals 2. Now we can go about actually getting this into a single line equation and removing this denominator. So I'm going to times both sides by this denominator here. I'm going to times that over, and that's going to put it next to this 2. So it's going to be 2 lots of 3x squared plus x minus 2. So if I rewrite this now as a single line, let's bring it up here. We get 26x minus 4 equaling, and let's expand this bracket here, 6x squared plus 2x minus 4. And if we rearrange this, I'm going to make it equal 0 on the left, so I'm going to minus 26x, and I'm going to add 4 to both sides. So I'm going to minus 26x and add 4, and that's going to allow me to get 0 over here. Obviously it's a quadratic and we need it to equal 0. It doesn't matter whether it's on the left and right, but I want to avoid having a negative 6x squared and having an extra step there. So 0 equals 6x squared. Take away the 26x from 2 gives us negative 24x. And then add 4 to that minus 4 gives us 0. So there we go, it doesn't have a number at the end. So we can actually solve this now. So I can solve this, but it doesn't have a number at the end, so it's not going to go into a double bracket, which it might do if it has a number at the end. So we might have two solutions like in that way, but I'm going to see what solutions I get this way. So if we factorise this to start with, I could actually simplify it. I could divide both sides by 6. And if I do that, let's see what we get. Divide both sides by 6, and we get 0 equals x squared minus 4 x. There we go. Now I can factorise it as well. I've just saved myself a bit of time there. So if I factorise it, we get x equals 0 equals x brackets x minus 4. There we go. So now it's factorised. Hopefully remember as well, we've done this on a couple of other questions. This x value here has no number with it, so one of our solutions is x equals 0, and this one here we flip the sign, so x equals positive 4. And there's my two solutions, x is 0 and x is 4. And there we go, that's that solved. Obviously lots of different algebraic fractions that you could have. You could be timesing and dividing them, adding or subtracting them, solving with them. Okay, always just look to follow normal fraction rules and obviously looking to factorise where possible in these questions. Okay, so we've got a functions question. So we've got f of x is 2x minus 4 and g of x is x squared plus 5. Now the first one we're going to have a look at is this here, so working out an inverse function. So an inverse function just means basically doing it in reverse. So the function of f is 2x minus 4. It times a number by 2 and then takes away 4. There's a nice way of doing this algebraically. We can change that f of x piece there for a letter. I'm going to just change it for the letter y. So y equals 2x minus 4. And I'm just going to rearrange it to make x a subject, which is hopefully quite nice and easy in comparison to the one we looked at earlier. So add 4 to both sides. You get y plus 4 equals 2x. And then divide both sides by 2. You get y plus 4 over 2 equals x. There we go. I'm just going to rewrite that with x instead of y, and that'll be the reverse function there, the inverse function. So instead of being y plus 4, it's x plus 4, so x plus 4 over 2, and that equals the inverse function of f, so f minus 1 x. There you go, and that's how you do your inverse function. And that can be done for any type of function here. Just swap the x and y, rearrange it to make x a subject, and then rewrite it. Okay, on to the next one. It says work out g(f(x). So you could be asked to put a number in. This isn't actually asking us to put a number in. It's saying g(f(x), which means I have to sub one of the functions into the other. So if you read this, it means what is the function of g when you put f into it? So what is g when you put f into it? So, well, g's up here. So all we've got to do is put f into it. So if I stick f into there, and the way that I do it is I stick the function of f in a bracket, and I'm just going to replace the x value here with that bracket. And if I do that, I get 2x minus 4 in brackets squared, because it's x squared, and then plus 5. So really there is an expression for that, but I'm going to completely expand it and simplify it all down. So we have a double bracket, we have 2x minus 4, and another 2x minus 4. And then once we've expanded that, we just need to remember to add 5. So if we expand that, and again, I'm going to skip some steps here. I'm going to do 2x times 2x, which is 4x squared. And then we've got 2x times minus 4 and 2x times minus 4 again. So minus 8x is minus 16x. And then 4 times 4 gives us 16, but we're going to add 5 to that. So that'll give us 21, so plus 21. And there's your expression for that. You could have had this written in a different way. You could have had f gx, and in that case you'd do it the other way round. It says what's the function of f when you put g into it, so you put your bracket round g and slot it into the x place in f. So you can have two different ones there as well. Just got to make sure that you do them in the right order. You could also be asked to sub a number in, so it might say something along the lines of f, let's do it the other way round, fg, I don't know, 2. And in that case that means what's f when g is 2? So you put 2 into g, and if you put 2 into g you get 2 squared plus 5, which is 9, and then you put 9 into f. So what is f when g is 2? Well, when g is 2 we get the answer 9, so you stick 9 into f. So putting 9 into f, which is our first function there, you do 2 times 9, or 2 lots of 9, take away 4. 2 lots of 9 is 18, take away 4 is 14, so that would be our answer there if it asked us to sub a number in. But these ones are a bit harder when you have to put a function in and remember what order to do it in. But just remember the way you read it. So for this one we looked at, what is g when you put the f function in? And there's some functions for you. Okay, so looking at some iterations. Now this says using x to the n plus 1 equals 5 over xn squared plus 2, and then it gives us x naught equals negative 2.5, find the values of x1, x2, x3. So all this is a process to finding estimates to a solution of an equation. Now the equation is not given to you in this one, but it does give us this iteration formula. Now this little n plus 1 here just means to find the next estimate. So if you read that in words, it says to find the next estimate, you do 5 divided by, and this little xn here means the current estimate, so the current estimated solution squared, plus 2.
and then it says with x naught equals 0, and x naught just means your starting number, and it says start with negative 2.5. This is quite nice and easy actually when you do these. All you've got to do is sub that number into the equation. So don't be put off by the language here. That just means to find the next number. So to find the next number, all we're going to do is in our calculator we're going to do 5 divided by, and this will give us x1, our first solution, that's what x1 is. 5 divided by the current number squared, so negative 2.5 squared. And again, you've got to be super careful here because you've got to put this in a bracket. So the current number squared, so when we're putting a negative number in, we want to put it in a bracket. And then plus 2. So to find the current number, to find the current solution, or the next solution, you do 5 divided by our starting number squared and add 2. So literally just typing that into your calculator. So open up your fraction button, make it look exactly the same as that, 5 on the top, negative 2.5 on the bottom squared, and then come out of your fraction and plus 2, or press equals and then add 2. Now you get a decimal for this, you get either a fraction 14 over 5 or 2.8. So there is our value of x1. Now obviously now that is our current solution, so 2.8 is our new number. So I'm going to repeat the process here, but instead of putting negative 2.5 in, I'm going to put this 2.8 in. So where I put it in here, that number is now just going to be 2.8. And it's quite a nice little trick you can do on the calculator here. As long as you don't press equals, you can do 5 over, and you can either type this number in, 2.8 squared, or you can just press your answer button. So there's an answer button next to your equal sign, usually just says ANS, and you can just put the answer in there. And it's a lot quicker if we have to do lots of solutions here, but for this one it's quite nice and easy for me to type it in, so I'm just going to write it. There we go. So you go back on your calculator into your formula, make sure you haven't deleted anything, press your answer button and it will put 2.8 in for you. Press equals again, and again this is where the answer button comes in, because the number that we get here is absolutely horrible and I'm going to have to write it all down. So it gives me the answer 2.637755,102, and that is my value of x2. Now I don't really want to write that in over and over again. You can do as long as you've written it all down, but because I can use this answer button now, I'm just going to not touch my calculator screen at all, and I'm just going to write down what x3 is. So on my calculator screen it currently says 5 over answer squared plus 2. So all I'm going to do is just very carefully, making sure you haven't deleted anything off your calculator, I'm just going to press equals again, and it gives me my next answer. It subs that 2.63 number in for me, and I get the answer 2.718622914, and it doesn't say to round them, so I write down all the numbers on my calculator display, and there they are. There's the values of x1, x2 and x3. Basically just subbing a number in, getting an answer, and then subbing your answer back in. So remember, these are estimates to the solutions of a particular equation. Now the equation wasn't given to us, but these are the estimates to the solution of that equation. Okay, so that's what we use iteration for, and there's your iteration. Okay, so we've got, and I can just see down here, we've got some graph transformations. So it says the coordinates of the minimum point of a curve are 3 and -5. Now there would be an equation for this curve, but it's not written down on this question. Okay, and it says write down the coordinates of the minimum point with these equations. So given that that line, that curve there has an equation, what we're going to do to the function over here. So there's a few rules to remember with this one. If the number in these functions over here is next to the x, or whether it is outside of the x and it's next to the y, let's say, there we go. So if it's next to the x, it does the opposite of what you'd expect it to do. We'll talk about that in a sec. Okay, and if it's next to the y, it does what you expect. We'll talk about what you'd expect in a second. Okay, if it's next to the x, it affects the x coordinate. And if it's next to the y, it affects the y coordinate. Well, let's have a look at this to start with then. So part A there, we've got a +2 next to the x. So it's going to affect the x coordinate, but it's going to do the opposite of what we'd expect. Now we would expect a +2 to add 2 to the x coordinate, but because it's in the bracket there, just like when you can sort of almost link this back to when we're solving and factorising, and when you get a bracket and you flip the symbol, it does the opposite. We can kind of almost link it to that. But what it does is it actually takes 2 away from the x coordinate. So that's going to mean it's going to be not 3, but 1. So 1 minus 5. There you go. Does the opposite of what you'd expect. We take away 2 from the x coordinate.
Now on to the next one, and this is where this kind of has a little bit of difference going on. We've got a minus there. Now it's not next to the x coordinate, so we say it's next to the y. So as it's not next to the x coordinate inside the bracket, it affects the y coordinate. But a negative symbol there just flips the sign in front of the number. It doesn't do the opposite or not do the opposite of what you'd expect with a negative symbol. It literally just changes it from negative to positive or positive to negative. So it doesn't affect the x coordinate because it's not in the x bracket. So it stays as a 3, but the y coordinate goes to positive 5. There you go. So it changes it from negative 5 to positive 5. Okay, so the negative could be inside the bracket. If it was, it would change the symbol on the x coordinate instead. Look at the next one here. We've got a minus 3 at the end. Now it's not inside the bracket, so it does what you expect. And we would expect minus 3 to subtract 3 from the y coordinate. So it doesn't affect the x coordinate, but it does subtract 3 from the y coordinate. So minus 5 would go down to minus 8. There we go. Every time I'm just referring back to this coordinate here. And on to the last one. We've got 2x in the bracket. Okay, for this one, so it does affect x because it's inside the bracket next to the x, but that means it does the opposite of what you'd expect, and that means 2 times x, so you would expect that to double the x coordinate, but if it does the opposite, it halves the x coordinate. That's the opposite of timesing by 2 is dividing by 2. So instead of it being 3, it would be 1.5, and it doesn't affect the y coordinate, so it would be minus 5. There you go. So obviously lots of different variations of this. You could be asked to draw the graph as well, but you can always just take this approach, pick a coordinate on the graph and see how it actually changes the coordinate. So it might be that you actually have to move it right, move it left, move it up or down, stretch it or reflect it with one of these negative parts outside or inside the bracket. Okay, but always just remember these little rules. So if it is in the bracket next to x, it does the opposite of what you'd expect and affects the x coordinate. And if it's outside of the bracket, which I put next to y there, it does exactly what you'd expect, but it affects the y coordinate. Okay, so obviously different variations of these if we change our pluses and minuses. On to some algebraic proof. It says prove that the sum of the squares of 2 consecutive odd numbers is always 2 more than a multiple of 8. Now there's loads of different questions on algebraic proof, and again I'll have a video with lots of these different examples, but here's just quite a good one here. So it says prove that the sum of the squares of 2 consecutive odd numbers. So there's a few numbers that you need to know. So any number we refer to as n. An even number, well, an even number, if you get any number and times it by 2, it becomes even. So an even number in this proof we're going to say is 2n. Now to make a number odd, we can just think, well, okay, well, times it by 2 makes it even, and then add 1 to it. So an odd number is 2n plus 1. Okay, so times any number by 2, you get an even number, add 1 to it, and it becomes odd. So 2n plus 1 is our little expression we're going to use for an odd number. But it says the sum of the squares. So that means add them together and once they've been squared, and it's 2 consecutive odd numbers. Well, I've got one odd number there, 2n plus 1, so my next odd number would be 2n plus 3. Okay, to get to the next odd number we'd add another 2 to it, so it'd be plus 3 instead. So the numbers that I've got 2n plus 1 and I've got 2n plus 3. And it says the sum of the squares, which means we've got to square them. So I'll square them both. And the sum means to add, so we're going to add them both together. And again, lots of different variations we could have here, but we've just got to square these. So if I square this first one, that's a double bracket, remember, so we'd get 4n squared plus, we'd get 2n and 2n, so 4n plus 1. And for the one on the right here, we'd get 4n squared again, but it'd be plus 6n plus 6n, so it'd be plus 12n. And then 3 times 3 is 9, so plus 9. Right, let's have a look what happens when we tidy this all up. So adding together the 4n squareds gives us 8n squared. 4n plus 12n is 16n. And then 1 plus 9 is 10. Now what I could do at this point is, if it had said prove that it's always even or prove that it's a multiple of 2, I could just factorise it by 2, and that would show that any number that I sub in there would be multiplied by 2, but it doesn't say that. It says it's always 2 more than a multiple of 8. So I'm looking to try and factorise this by 8. And if you have a look, well, the first piece divides by 8, doesn't it? I can do that. Let's have a look. Divide that by 8 or factorise it by 8, we get n squared. The next one, we can divide by 8 as well. We get 2n. 16 divided by 8 is 2. But I can't divide this last piece by 8. 8 does fit in once though, doesn't it? But it leaves us a remainder. And my remainder would be 2. So if I think about that over here, if I split this number up, and you can do it like this or think of it as a remainder, but if I was to write plus 8 plus 2 instead of plus 10, the 8 would divide by 8, giving me this plus 1,
and then I would still have this plus 2 at the end that I've not factorised. And that there proves that. It proves that it's always 2 more than a multiple of 8. If we subbed any number into this bracket here, so any number, it would be multiplied by 8, and then at the very end we would add 2. So that there proves it. Okay, we would multiply everything by 8, meaning it's a multiple of 8. That means multiplied by 8. And then at the end we would add 2. So that proves that any number we sub in there into this expression is always going to be 2 more than a multiple of 8, because we times by 8 and then add 2 at the end. And that's the end of that one there. Again, lots of examples on this that I've got a good video on. On some coordinate geometry, we've got a straight line passes through the coordinates 0, 1 and 10, 6. Find the equation of the line perpendicular to AB that passes through B. So in order to find a perpendicular line, we need to find what the gradient is first. So if I have a look at A and B, we've got 0, 1 and 10, 6. So to find the gradient, we can do the change in y over the change in x, which you might also refer to as rise over run. So the change in y goes from 1 to 6. So the change in y there is 5, from 1 to 6. The change in x is from 0 to 10. So from 0 to 10, that's 10. And if we simplify that, that gives us a half. And I always leave these gradients in fractional form rather than as a decimal. So the gradient is a half, and I always write m equals a half, because we know we're looking at line equations, which is your y equals mx plus c. So m is a half. It says find the equation of the line perpendicular to that passes through B. So we're using this equation. So a perpendicular line, we do the negative reciprocal. So to get my perpendicular line, which I'll call MP, you flip the fraction over to get the reciprocal, so 2 over 1, and you change the sign, so it's negative 2 over 1. And negative 2 divided by 1 is just negative 2. So the gradient that we're looking at here is negative 2. So what I'm going to do is I'm going to write out what the equation of a line always looks like, which is y equals mx plus c. And I'm going to plug this piece into the equation of my line, because I've now got the gradient. So we've got y equals negative 2x plus c. Now it says it's got to pass through that point 10, 6. So if it's got to pass through 10, 6, I'm just going to stick these numbers in, remembering that we have an x coordinate here and a y coordinate here. So if I stick those in, we have y is 6, so 6 equals negative 2 multiplied by the x coordinate, 10, plus c. Now we just need to solve this for c. So we have 6 equals, multiply these, negative 20 plus c. Add the 20 over, and you get 26 equals c. So you found your y-intercept there. All you've got to do is finish this question off, put all the pieces back together. So you have y equals minus 2x, which we have already had up here, but now we've got c, and that's positive 26, so plus 26. So y equals negative 2x plus 26. Again, you could rewrite that in another way. You could write y equals 26 minus 2x. I'm just going to leave it like that because it's fine to write either way. And there's the equation of that perpendicular line. Okay, and the last one here, we've got a circle A has the centre 2, 5, and the point P, 11, 8, lies on the circumference of the circle. Find the equation of the tangent to the circle. Now what we know about tangents is they are perpendicular to the radius, okay? So a tangent is perpendicular to the radius. Let's think about that. Perpendicular to radius. Now it can help with these types of questions to draw a little bit of a diagram, just have a think about what this actually might look like. So if I have a think, a bit of an axis here, it says the centre's at 2, 8. So I'll draw a little sketch, not the best sketch here, but 2, 8. And it says the circle, point P is 11, 8. Let's imagine that's over here somewhere. So we've got a tangent coming off the circle, and that's what it looks like. So there's a few, that's a really bad centre there, let's change that. It's a little bit better. There we go. So this is a really, really general sketch of what it might look like. Okay, and it says that the point, the centre has a coordinate 2, 5, which is there, and point P is up here, 11, 8. Now, there's lots of information we can find on this question here, but let's just have a look and just see what it's actually asking. It says find the equation of the tangent. So in order to get the equation of the tangent, I need to know what the gradient of it is. If we think about the radius here, okay, bearing in mind that they're perpendicular, that's what we've already stated, it forms the right angle. Could we find the gradient of the radius? Now we've got these 2 points, so we've got 2, 5, and that definitely attaches to 11, 8, which is on the circumference. So I can find the gradient of those points. I can do the same as we've done in the last question. I can do the change in y over the change in x. And that's change in y goes from 5 to 8, which is 3, and the change in x goes from 2 to 11, which is 9. So my gradient is a third. There we go. So my gradient, or m,
is a third. So looking at the tangent, which is perpendicular, I can say that the gradient of that is, well, flip it over, would give us 3, change the sign, -3. So there's the gradient of the tangent. So if we stick that into our line equation, as the tangent is a straight line, we get y equals -3x plus c. And we know that it passes through this point 11,8. Okay, otherwise it wouldn't be on the circumference of the circle there, which it says it is. That's where the tangent meets it. So what I'm going to do is I'm going to stick 11,8 into the equation of the line, just like I did on the last question. So we get 8 as y equals -3 multiplied by 11 plus c. And again, exactly the same as the last question, we can solve this now. So 8 equals -33 plus c, timesing those out, add the 33 over, 41 equals c. So now I've got the y-intercept of that line as well. Now if we put this all together, we've got our equation. So y equals -3x plus 41. There we go. And there's the equation of the tangent. A few other things that you could be asked about this question though. Let's have a look. There we go. You could be asked to work out maybe the length of the radius. So if we go back to our diagram over here, in order to get the length of the radius, we'd have to use a little bit of Pythagoras. So bringing that down there, you've got a little right angled triangle you can draw in, and it goes from 2 to 11, which was a run of 9 there, and a rise of 3, so you could do 3 squared plus 9 squared, so you could actually get the length of the radius there. What would that be? 3 squared is 9, 9 squared is 81, so square root of that is root 90. So you don't need it for this question, but you could say the radius is root 90. You could also be asked to write down maybe the equation of the circle or something like that, but just something else to be thinking about if you ever want to find the length of the radius. You can find it by using a bit of Pythagoras there. Not that we needed it for this question though. Right, okay, that's the end of algebra. Okay, so moving on to some geometry. So we're going to start off with this volume of a frustum. Now you would be given the volume of a cone formula, and that is volume equals 1/3 pi r squared h, where r is the radius and h is the height. So if we have a look at this frustum here, the only thing it doesn't give us is this length across the top. But if we have a look, the height of the little cone on top is 20, and the height of the big cone, if it was still there, is 40. So it's half the size, so the diameter there is 15. Now in order to work out the volume of a frustum, you've got to work out the volume of the big cone if it was there, and we're going to take away the little cone that's been chopped off the top. So I'm going to start off with the big one. So I'm just going to label this the big cone, and I'm just going to plug the numbers into my calculator. So it's 1/3 times by pi times by the radius squared. Now careful, because it's not 30, it's 15, half of that, so 15 squared times by the height, which is 40. So typing that all into the calculator, and I can leave that in terms of pi, or I can write out the full decimal, and it comes out as 9424.777961 centimetres cubed. Now for the small cone on top, there we go, we can work out the volume of that as well. So it's 1/3 times pi times the radius squared, careful, so it's half of 15, so 7.5 squared, and times that by the height of that cone, which is 20. And that gives us a volume, and again if we just type that in, let's have a look. So 1/3 multiplied by pi multiplied by 7.5 squared times 20, and that gives us a volume. Again, I could leave it in terms of pi, but 1178.09724.5, and again that's centimetre cubed. So in order to work out the volume of what's left when the little cone's been cut off the top, we just need to do the big cone, subtract the volume of the little cone there. So I'm just going to subtract this away from that, so subtract. And again, I'm just going to do that on the calculator. So 9424.777961, take away that answer there, leaves us with a total volume of 8,246. And I'm going to round it to 2 decimal places, although you would be asked how to round it in a question, but I'm going to go for 0.68 centimetre cubed. Just be careful what the question asks for. Obviously if it said 1 decimal place, it would be 0.7. It might even just say 4 or 3 significant figures, in which case you just got to make sure you just round it how the question's asked. But there you go, that's using the volume of a cone formula on a frustum there, which is a little bit more interesting than just doing a normal cone. Next one here we have a hemisphere, and it says work out the volume of the hemisphere. Now again we'd be given the formula to work out the volume of a hemisphere, and volume of a hemisphere is 4/3 pi r cubed, and that is our final volume there. Oh, let's make sure that says, that's a rubbish 3, let's change that.
4/3 pi r cubed. So all you've got to do is stick the numbers in the formula again. So if I want to work out the volume, all I have to do is in the calculator I do 4/3 multiplied by pi multiplied by 8 cubed, and we'll get our answer here straight away. So fraction button, 4/3 multiplied by pi multiplied by 8 to the power of 3. And we get a volume here of 2144.66, again if I round it to 2 decimal places, centimetres cubed. Just remember obviously to write all the numbers down and only round it once you've been asked to. Okay, so once you've got your total volume of your sphere there, just remember this is a hemisphere, so it's half the size of a sphere, exactly half. So I just need to divide my answer by 2 here. And once we divide that by 2, we get a final answer of, let's have a look, 1072, so 1072.33. Again, I've rounded it there, centimetres cubed. And that would be your final answer here for the volume of a hemisphere. Not forgetting as well, you could be asked to work out the surface area. And if you're asked to work out the surface area, again, it gives you the formula of a sphere. And the surface area of a sphere is 4 pi r squared. So again, if I was to work out the surface area of this one, it's a little bit more complicated, but only in the sense that we work out the full surface area. So we do 4 times pi times 8 squared. If I just go for this, let's work it out. 4 times pi times 8 squared. That gives us a surface area of a sphere being 804, and it's 0.25 as well. Again, we'd have to halve it because it's half. Okay, so half of that would give us a surface area of 402.12. And that is obviously a surface area, so it's centimetres squared. But if you're working out surface area, you've got to make sure you don't forget as well the circle sitting on top there, because it's the total surface. And the area of a circle is pi r squared. So we can work out the area of the circle as well. If we just do that, pi times 8 squared, we get an area of the circle there of 201.06. And you would just add these two numbers together to get the total surface area. So if you add 201.06, we get a total surface area of 102.12 added to that, gives us 603.18 centimetres squared. Again, so I know we were looking at volume there, but just thinking about if you had to do the surface area as well, how you'd approach that when you've got a hemisphere and you've got to make sure you halve them and add on the extra circle. Okay, so we've got some similar shapes. Two cones are mathematically similar. The height of cone A is 4 and the height of cone B is 10. Now you can always imagine what this is going to look like. You can always draw yourself a picture if you haven't been given one. And we've got a bigger cone. So we've got a height of the smaller one being 4 and a height of the larger one being 10. Now straight away you can work out a scale factor between these two. If they are mathematically similar, it just means one's an enlargement of the other. So I can do the bigger length, 10 divided by 4, and it gives us a scale factor of 2.5. Now when it comes to scale factors, that is our length scale factor, and always label it length scale factor. Now there's two more scale factors we could want to look at, and that's the area scale factor or the volume scale factor. And to get from the length scale factor to the area scale factor, you square it. Okay, so we square the scale factor. To get from the length scale factor down to the volume scale factor, you have to cube it. So if we just have a look at this question here, it says the volume of cone A is 40, work out the volume of cone B. So that's cone A is the smaller one in this case, I should probably label that A and B. And it says the volume of this one is 40. So in order to find my volume scale factor, I need to do 2.5 and cube it to get a volume scale factor. So we're going to do that on the calculator. 2.5 cubed gives me 15.625, and that's my scale factor in terms of the volume. So the volume of cone B is going to be 15.625 times bigger. So in order to get that volume there, we're just going to multiply 40 by 15.625. So times that by 40, and we get a volume here of 625 centimetres cubed. There you go. Just remembering as well, if we were going from the bigger down to the smaller, we'd have divided by the scale factor, but as we're going smaller to bigger, we're going to multiply. Let's have a look at a different one. So a similar question, two cylinders are mathematically similar. We've got cylinder A and cylinder B. Now it says cylinder A is 160 and cylinder B is 20. So A is my larger one. So if I just draw a little basic diagram of this, we've got A and we've got B. There we go. And this time it says, actually gives me the volumes. So it says the volume of A is 160 and the volume of B is 20. So again, if I find a scale factor here, I can do the bigger one divided by the smaller one. 160 divided by 20 gives me a scale factor of 8. Now, if I'm thinking about this area scale factor, length scale factor and volume scale factor, there we go. This time, I've got the volume scale factor, and that is 8. But I can't get from volume straight to area. Now, if you remember, to get from length to volume, we had to cube it. Okay, so to get back from volume to length, we have to cube root it. So if I do the cube root of 8, that tells me that the length scale factor is 2. Now the question here is saying, it asks me to work out the surface area. So I need the area scale factor. And if you remember just from the last one, to get from area, length down to area, we square it. So that'll be 2 squared, which would be 4. So my area scale factor is 4. Okay, so whenever you're given an area or a volume, you have to go back to length first to then get back to an area or a volume. So my scale factor is 4 for the area, and it says the surface area of cylinder A is 40, so that's the bigger one. I'll just write area rather than surface area. So to get from the bigger one down to the smaller one, we're going to have to divide by that scale factor, which is 4 for our area, and 40 divided by 4 gives us 10. So we get a surface area of 10 centimetres squared. Right, there we go. There's thinking about some similar shapes. Okay, so we've got a transformation here. It says enlarge shape P with a scale factor of -1/2 with a centre of enlargement 0, 0. So always mark out your centre of enlargement first. And an enlargement with a negative scale factor and a fraction here means that we've just got to do this very, very carefully. Now, the first things first, you need to pick a point on the shape and just figure out how you get from the centre of enlargement to that point there. And if I just count that, that's 1, 2 to the right, and 1, 2, 3 up. Now all I need to do this, and it's going to be quite small on this diagram, is I just count in the opposite direction by whatever the scale factor is. That's what the negative is. So rather than going from 0, 0, rather than going right and up, I'm going to go left and down. But it's a scale factor of 1/2, so I need to also halve those distances, just as if it was -2, I would double those distances. But for -1/2, so I'm going to go left 1 rather than 2. And I'm going to go down, rather than going up 3, I need to go down 1.5 or 1.5. So 1.5 gets me to there. There we go. So that's 1.5. I'm going to do the next one in a different colour, so I'm going to pick this point here. And let's just think how we get to that. Let's get rid of some of these markings here. There we go. So to get to that, we go 1, 2, 3, 4 across, and 1, 2, 3 up. So I'm just going to halve that again. I'm going to go 2 left rather than 4 right. So 1, 2, and then that 1.5 down, which again gets me down to there. There we go. And that is that point. Then again, I just need to repeat the process for the last one. You might be able to start to do these in your head once you've had some practice, but if we do the last point here, being the top one, let's just see how we get there. So it's 1, 2 across, just like it was to that red one, and then we've got to go up 1, 2, 3, 4, 5, 6, 7. So half of that's going to be 3.5. So I'm going to go 1 to the left. Okay, so I need to go down 3.5, 1, 2, 3.5, just there. There you go. Obviously you can do all this in pencil to keep this all nice and tidy, but when you've got a negative scale factor, you're just going to go backwards in the opposite direction by whatever that scale factor is. Obviously join it all up nice and neat, and there we go. And that is that one there. Just always go back and double check. So it was 7 up, so we went 3.5 down. That's absolutely fine. The other one was 3 up, and we went 1.5 down, half of that. And the other one there, perfect. Okay, so you can see with these, it does actually get bigger, and it gets bigger or smaller, and it rotates 180 degrees, and that's what a negative enlargement does to a shape. Okay, so we're going to have a look at another one here. Okay, so it says describe the single transformation that maps shape B onto shape A. This is quite nice. Hopefully you can tell that it's an enlargement, okay, because obviously one's got bigger and smaller, and we're going from B to A. Now what you can do is you can get your ruler, and we're going to have to try and do this quite carefully, but you get your ruler and you join up the similar points. Now the similar points are here and here. Okay, obviously it's been rotated 180 degrees. Now if you get your ruler and join that up, you end up with a little line like that. And then you just do that for all the other points. So I can probably get away with just doing 2, we'll have to wait and see. So if I join up these 2 similar points here, there we go, they join up just like that. And what you'll find is that there's this little crossover point, and that tells you where the centre of enlargement is. So I know that it's an enlargement, I've already got that, so I'm going to have to state it's an enlargement. Okay, so it's an enlargement. I've got to get what the scale factor is. I haven't got that quite yet, but I'll have a look. We know it's negative as it's getting this 180 flip. So we know it's negative. We'll come up with the number in a sec. And I know where the centre of enlargement is. So centre of enlargement. We just write down what that coordinate is, and it's 2, 2. So centre of enlargement 2, 2. Now to count that scale factor, we're just going to count this side here maybe, and this side here, and just see how much bigger it's got. So that's gone from a length of 1 to a length of 3. So that is a -3 scale factor. So it's an enlargement, scale factor -3, centre of enlargement 2, 2. And you can use that approach for any of these enlargements, whether it's negative or not. Also, you might just want to note here that if it had been from A to B, it would have been the other way around. It would have gone from 3 down to 1. And my scale factor instead, if I was going from A to B, it'd be exactly the same description there, but my scale factor would be -1/3, because it's getting 1/3 of the size going the other way. Okay, so two different ones, but the description would be exactly the same there. Okay, so we're going to have a look at some circle theorems. For the purpose of keeping this video as short as we can, I'm only going to go over a couple of them and just how to approach the question. If you want to have a look at every single circle theorem, how to tackle every type of question, you'll have to look at my circle theorems video. Now, some information to go along with this. I'm going to say that AP and BP are tangents. There we go. So when it comes to tangents, they meet at equal length. That's one of our circle theorems. So these two lines here are equal length, meaning that APB, that triangle there, is an isosceles, meaning that the base angles, these two, are the same. So there we go. We can start to figure out some of the angles here, because if we do 180, the angles in a triangle, take away 86, it leaves us with 94. That we can split in half to share it between our two triangles there. So 94 divided by 2 is 47. So both the angles at the bottom of the triangle there are 47. There we go. And as with all these questions, it always says to state your reasons. So you would say tangents meet at equal length, therefore this triangle is an isosceles, okay, and writing that down. Okay, on to the next bit. We've also got, and it doesn't say it here, but O is the centre of the circle. Now O to B there is a radius, looking at this line just here. And a radius meets a tangent at 90 degrees, meaning, and always draw this on the diagram when you see a tangent meeting a radius, we've got a right angle just here. So we can work out the value of x, because if the full angle is 90, we're going to do 90, take away the 47, and that leaves us with 43 degrees. The important part with this question is to make sure you write down all those reasons. So we would write that tangents meet at equal length, isosceles base angles are the same, and then our final reason for this bit of the working out, the tangent meets the radius at 90 degrees, and therefore we could do 90 take away 47. Okay, a different circle theorem question with some different circle theorems within this one. So if you have a look, we've got these points A, D, C, B around the circle, and that forms a quadrilateral. And these are called the cyclic quadrilaterals. And the rule here is that opposite angles add up to 180. So we've got the 70 over there, so opposite that is the y. And opposite angles have to add up to 180, so we could do 180 take away 70. And it gives us our answer of 110 degrees. And our reason for that, which we would have to write down again, is that opposite angles in a cyclic quadrilateral add up to 180. The next one here is to find this angle x, and that's going to involve one of our other circle theorems. And when you've got these points made at the centre, I'm just having a look at points D and B, and I always do this with a little highlighter. But if I make this angle 70 here, I can also, from the same 2 points, make this angle here at the centre. And that's one of our other circle theorems. Angles at the centre are double angles made at the circumference from the same 2 points. So to work out angle x, and this first one we did was y, to work out angle x we would just do 70 times 2, double it, and that would give us 140 degrees. And again, that would be accompanied by the reason angles at the centre are double angles at the circumference when they're made from the same arc. So our two answers here are 110 degrees and 140. Again, just a few little bits of circle theorems there to be having a thinking about, and making sure that you are writing down all those reasons. That's absolutely crucial for these. Okay, so we're on to some congruent triangles. It says prove angle ABD is congruent to CBD. Now if you have a look, ABD is the triangle on the left and CBD is the triangle on the right. Now in order to prove triangles are congruent, we need to look for similar sides and similar angles. Now the first one that pops into my head is the line B to D, this line in the middle. Okay, I'll highlight that. This line B to D in the middle is the same for both triangles. So I could prove a side straight away. So I can say a side, I've got BD is the same in both. So both triangles already share a similar side, or exact same side. BD is the same in both. And remember, we're trying to prove that they're congruent, which means that they're exactly the same. So let's get rid of that. We can have a look at another one now. Can we see any other sides that are the same? Well, we've got these little symbols, and I've already got an arrow pointing to two of them really. We've got these little symbols on all of them, which means that all of those lengths are the same length. So we could state any of these are the same now. We've got AB, this one here, number 1, is the same as BC, number 2. So I can do another side. So I can say that AB equals BC, and actually that's given to us in the question, so I would just have to say given in question. There we go. And actually using that same logic there, we could actually prove that these two down the bottom, which I'll label 3 and 4, are the same as well, because they're all the same length. So I could prove another side. So I could say that AD equals CD, and again that's given in the question. There we go. So all I have to do is state why that they're congruent there, and I can just say, and I'll just write this down the bottom, I can say therefore they're congruent, okay, because the SSS rule here, so side, 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 congruent, and we're using the SSS rule. Okay, so there's other things that you can look for as well. You can have a look for angles. Obviously there's a few of these that you can use. This is just an idea of how to approach it and how to lay it out, just labelling what you found. But because these are obviously isosceles triangles, so this one on the left here, we've got two sides at the same length, so we know that the base angles are the same here. Therefore, as they're all the same length, those base angles must also be the same as the base angles on the other triangle. So we could use that as well. And if those angles are the same, then this angle at A has to be the same as the angle at C, so actually we could prove all of them. So there's a lot of different types of questions here, a lot of different proofs, but there's just an idea of one of them and how to lay it all out. Okay, so we're going to have to work out some missing lengths in this triangle. Now it's not a right-angled triangle, so to find missing lengths and angles we can use either the sine rule or the cosine rule. And these are rules that you're going to have to remember. But we're going to have a look at one to start with and how we know when to use it. Now the first thing you do is you try and identify in a triangle for first of all what we're looking for, which is AB. So let's label that X. Now what I look for straight away is, do I have pairs of opposites? So I have this pair of opposites here, and I've got both of those. And then I've also got X opposite to this angle. So I don't have X, but it's in one of my pairs of opposites. So when we've got this scenario where there's two pairs of opposites, we can use the sine rule. And we only ever need part of the sine rule, so I'm just going to use A over sine A equals B over sine B. Also equals C over sine C, but we only ever need to use two of them here. So let's have a look. We need to label this up. Now I'm going to completely ignore the letters that are on the actual triangle itself. I'm going to label this angle A, which it already is, and this side little a opposite that, and then this angle B, and the one opposite little b. And all I need to do now is stick all the numbers into the formula. So let's have a look. A is 12, so it's 12 over sine the one opposite that, 55, is equal to B, which is our X, over sine B. Obviously you should already know there's two variations of this formula. We could have it flipped over, so we could have sine A over A equals sine B over B, but this is our one for side lengths, and we know that because our unknown piece is on the top, so we're able to isolate this now quite easily. So, sorry, I've written B there, it should be 20. There we go, sorry, there we are, 20. So all we need to do is times both sides now by sine 20. What you could do is work this out on your calculator and times your answer by sine 20, but I'm going to multiply it straight over so I can type it all in one go. So times by sine 20, and if we do that we get 12 sine 20, it goes onto the top there, over sine 55. There we go, and all we have to do is type that into your calculator, obviously just being careful that you put these angles in brackets. Some calculators are going to need you to do that. So if we type that all into the calculator, again, not forgetting you could just work out 12 over sine 55 first and then times it by sine 20, but I'm just going to go for it like this. So 12 sine 20 on the top, closing your bracket, over sine 55. And on the calculator, just writing down what you got 5.010353998. Now a question would normally say how to round this, so if we imagine it was 2 decimal places for this one, it would be 5.01, and it's a length, so
centimetres. Okay, so just obviously just be careful what the question says. Let's have a look at an idea where we've got to find the angle. Okay, so in this question, let's have a look. Work out the size of angle BAC. So let's identify that. That is here, BAC. Okay, so we're going to use the formula the other way around this time. So sine A over A equals sine B. That does not say sine B. Sine B over B. Okay, so plugging in our numbers, let's just label it up. So let's call this one A, as the A is next to it, that's fine. And again, I'm just going to write over this one, I'm just going to put B and B. Okay, just because of the way I've written my formula. So then sticking in all the numbers, what have we got? Sine A is sine X, so we have sine X over 20, equaling sine 43 over 14. Okay, so exactly the same approach as we did before. We can isolate the sine X by timesing both sides by 20. And again, you could work that right hand side out and times it by 20, but I'm just going to go stick it up the top there. So we end up with sine X equals 20 sine 43 over 14. And if we type that into the calculator now, what do we get? 20 sine 43 over 14, and we get an answer here. Let's write it over here. So we get sine X equals 0.97428 and a few more decimals. And obviously, just like normal trigonometry when you're doing SOHCAHTOA, to get the actual X here, we have to do the inverse of sine. So we're leaving that number on your calculator. You do shift sine, which gets you sine minus 1. Type in that answer or just press your answer button. So shift sine, answer, press equals, and I get an answer here of 76.9779. And again, a question would ask us to round it here. Just depends. So let's just go to the nearest degree. We go for 77 degrees. Obviously just making sure what the question says here, but let's just round it to the nearest degree there, so 77. Okay, so that's how you use the sine rule. Right, let's see how this question's different then. So work out the length of AB. So this one over here. Now straight away, looking at this, look, we've got a pair of opposites there, but I don't have any other pairs of opposites. I've not got anything opposite my 15, I've not got anything opposite the 12. So I can't actually use the sine rule here, and that is your clue, that is your hint here, that the sine rule's not going to work, and we're going to have to use the cosine rule. So another rule that you need to know, so the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Okay, so a being the side we're looking for, so we'll label this little a and this one big A, ignoring the letters on the triangle, and then labelling the other two sides, and they can be B and C, however you like. And from there, all you've got to do is stick these numbers in. It's actually quite simple to use when you know it. So a squared equals b squared, which is 15 squared, plus c squared, which is 12 squared, minus, and I'm going to stick this bit in brackets, 2 times 15 times 12 cos A, which is down here, which is 20. There we go. Right, so sticking that all in the calculator, let's have a look what we get. So 15 squared plus 12 squared minus 2 times 15 times 12 cos 20. Press equals, and I get a squared equals 30.7106 and a few more decimals. Now obviously that is a squared, and we don't want a squared, we want to know what a is, so we just need to square root both sides now. So square root, leaving the answer on your calculator, square root answer, and we get a equals 5.541719. And again, obviously you'd be asked to round this in a particular way in the question. Let's go for 2 decimal places, so a equals 5.54 centimetres. Right, there we go, and there's using a bit of the cosine rule. Okay, so working out the size of angle BAC, which again is this one at the top, and again just having a look, there are definitely no opposites because we've got no other angles, but the angle that we're looking for is going to be our A, and it is opposite 9. There we go, so the others can be B and C again. Now obviously here we're looking for an angle, so it's up to you if you choose to learn the formula. I tend to find that I just learn this formula, a squared equals b squared plus c squared minus 2bc cos a, and then I'm quite happy just rearranging that to get cos a on its own. So in order to do that, I'm going to get this whole
minus 2bc cos a. I'm going to add it to the other side. So we get a squared plus 2bc cos a equals b squared plus c squared. Now I can get rid of that a squared, so we can minus a squared from both sides, so minus a squared, and you get 2bc cos a equals b squared plus c squared minus a squared now. And now you can finish off this rearrangement. You can divide by 2bc just to leave you with cos a. So cos a equals b squared plus c squared minus a squared over 2bc. It's up to you. You can choose to just learn that formula if you want, but that's the formula we're going to use to find an angle. So plugging in all these numbers then just into my formula there, we'll get cos a equals b squared plus c squared, so 10 squared plus 5 squared, minus a squared, so minus 9 squared, all over 2 times b times c, so 2 times 10 times 5. Nice and easy typing that into the calculator. So fraction button, 10 squared plus 5 squared minus 9 squared, all over 2 times 10 times 5. And that equals, let's have a look, so cos a equals 0.44. And then same process again, we need to do the inverse of cos, so cos minus 1 of your answer. And you get, let's have a look, shift cos, answer, and I get 63.896. There we go, degrees. And again, we could round that, so we could just say 63 point, and let's just go to one decimal place, 63.9 degrees. Again, just reading the question. And that's how to use the cosine rule for finding angles. Moving on to the area of a triangle. So your area of a triangle formula, obviously not half base times height because we don't have the height here. So for any triangle, the area is half AB sine C. So half AB sine C, another formula there that you need to know. And let's just have a look at how we apply that. So sine C, this time the angle that we're going to use is going to be our C. So we'll call that C. This would then be little c, and the others will be A and B, and they can be A and B in either order. And then it's as simple as just sticking those numbers into a formula. So it's half times 5 times 8 times sine 41. There you go. Type that into the calculator. So half times 5 times 8 times sine 41. And we get the answer 13.12. If I round it to 2 decimal places, it's area, so that's meters squared, just being careful of the units. So 13.12 meters squared. There we go, there's using the area of a triangle formula. Question like this though, you might be given the area of the triangle. So it says the area is 80, so we're working backwards a little bit here. So we're going to use half AB sine C again. So half AB sine C, but this time it gives us the answer. So the answer to that half AB sine C has to equal 80. So let's just plug in all the numbers here. Again, C being my angle, and then A and B being my other lengths. So if I was to type this into the formula, we'd have a half times 11 times 16 times sine C, and it would equal 80. Now I can't actually work that out, but what I can do is I can work this bit out. So if I do a half times 11 times 16, we get the answer 88. So we have 88 times sine C equals 80. So we can rearrange this. Look, we can get both sides and divide them by 88, and that will just give us sine C on its own. So sine C equals, and 80 divided by 88 is, let's leave it as a fraction. Well, actually it is a decimal there, but it comes out as 0.90, and that is actually 90 recurring. There we go, I'm just going to leave it on the calculator screen. And then obviously to finish that off, you do the inverse sign again, just like we have on these other questions. So I'm going to do that over here to the left. So sine minus 1 of this number here, which is actually also a fraction, it's 10 over 11. Sine minus 1 of 10 over 11, or that 0.90 recurring. And we get the answer of 65.38 degrees. There we go, so we can find an angle as well, just working backwards if we're given the answer. And you can apply that logic there to lots of different questions where it gives you the answer, and you can use your formula backwards, just dividing everything over to the other side. Okay, so we've got a vectors question. It says B is the midpoint of AC,
So that's this point here, is the midpoint. So straight away that tells us, look, because you can see some of the vectors on here, that this must also be A. And again, there are so many different variations of vectors here. This is just one idea of how to approach it. But there's so many different types of questions you can get. We could spend an hour to 2 hours just looking at vectors. M is the midpoint of PB. So we've got a midpoint here, so that's halfway along. And then show that NMC is a straight line. So straight away I'd like to draw NMC in and just think about that. So that it's saying is show that that's a straight line. And we're going to have a look at some of the vectors on this line and see if we can get a common multiple or a common bracket, however you've looked at this before. So all I want to have a look to start with is that line N to C. I've got 3 vectors I can look at. I've got the full line from N to C. We've got from N just to M. So I can go from N to M. Or I could go from M to C. And they're all little parts of this line. Okay, the full line there, let's just highlight this. The full line, the first one that I've written is N to C, all the way. The second one I've drawn is N to M, from there to there. And the third one I can have a look at is from M to C, from there to there. Now it's up to you which one you choose. Sometimes some of them are easier than others. But the first one there, so this N to C, is quite simple for us to do. Now to get from N to C, I've got to move backwards up the line this way. And then I can go forwards along to C there. So that first part of the journey, going from, let's get rid of that, going from N up to A, and let's draw this in, so to go from N to A, so I'm just going to write this down, is minus 2b. You have to go backwards through that 2b. So from N to C, first of all, it's minus 2b. Then I can go from A over to C, doing 2a's, and that's positive, so plus 2a. There we go, so I've got minus 2b plus 2a. Now whenever it comes to these vectors here, you always just want to look to factorise them. So I'm going to move this out of the way, and I'm just going to see what does that factorise to. Now I can factorise it by 2, and I would get 2 lots of minus b plus a. And obviously we could write that in a slightly different way. I could swap the letters around if I want. I could write 2 lots of a minus b. Now if I can prove that one of these other vectors here that I'm looking at below has this bracket a minus b, then they must be on the same straight line because therefore they're going in the same direction. So let's have a look at one of them. So I can either look at N to M or M to C. It doesn't really matter, I'm just going to go with M to C. Either one here are going to be just as difficult for us to do, but that first one there is nice and easy, so always make sure you have a go at finding some of the lines. Now, that M letter here is halfway along PB, so I'm going to have to find the vector for P to B, and that's going to be my absolutely key one here, P to B. Because if I can't find the full length of the line, I'm definitely not going to find halfway along it. So if we look at how do we get from P to B, well that's actually quite simple. You can go from P up to A, and that's minus 3b's, so let's write that down. You've got the minus b to get to N, and then another 2 to get up to A. So minus 3b's. And then to get from A to B, you'd do a plus A moving along that vector there, so plus A. So that is my vector P to B. That's another very good one to always make sure you get that missing line where you've got a halfway point. Now in order to move halfway along that line, I'd have to do half of this vector. So to get from P to M, or from M to B, which is half of that, let's go for M to B as that's the quickest way for us to move there, M to B. We'd have to do half of this vector. So to times that by a half, I'm just going to write it as a half lots of minus 3b plus a. So half of that. Now if I expand that, I can actually add stuff to this as well, because that only gets us from M to B. If I draw that on, that gets us from here to here, doing half of that line. So expand that out. Minus 3 times a half is minus 3 halves. So minus 3 over 2b. Plus half of a, so half a. And now we can finish that off, because now we're at B, we can do our final little bit of the line, which is to go over here to C, and that's adding an additional a in there. Okay, so that's our last little bit, plus a. And if we add this all together, and let's see what we get. So we have minus 3 over 2b, I'm going to write this over here, that's not changing. So we've got minus 3 over 2b, and then we've got half a, add an a, and that gives us 1.5a, or another 3 over 2a. There we go, 3 over 2a. So let's write that down over here. We have minus 3 over 2b plus 3 over 2a.
So that is our vector there to get from M to C. Now all I need to do is just factorise this one. If you have a look, they both divide by 3 over 2. So I can take this 3 over 2 out the bracket, and if we divide them both by 3 over 2, we get minus b plus a. There we go. And I rewrote that a different way as well. I could write that as 3 over 2 brackets a minus b the other way around. And there we go. We've got that matching bracket there in both of them. Okay, so both share that common vector there, that common movement between the points on the diagram, n, m, and c. Again, you could have found n to m as well. We could have done the same thing, and actually, because we found this half, this one just here, we can actually just think if I was moving from n to m, so n to m, we would do plus b, and then half of that vector just there. And if we did do that, let's just do it over to here to the side. So this is from n to m, not that we didn't need this one, we only ever need 2. So from n to m I could do plus b, or just b, and then add to that this vector down here that we did in the green down there. So add to that minus 3 over 2b plus half a. And if we add that all together there, minus 1.5 plus 1 gives us minus a half, so we'd have minus a half b plus a half a. And again, we could factorise that by a half, so we get a half minus b plus a. And again, we get that minus b plus a there, which we can write in a different way. So we could have done any 3 of them. All 3 of them eventually give us this same bracket here. Okay, so we have the same multiple, it means it's on the same line. And there's a bit of vectors for you. And the last question here is just involving some circle sectors, but also involving a little bit of trigonometry as well. It says that this is an arc of a circle centre 0, and it wants us to work out this shaded region. So if we can work out the full sector, we can take away this unshaded triangle. So to work out the area of a sector, we would have to do pi r squared, so not forgetting your area of a circle formula, pi r squared, and multiply that by whatever fraction of the circle this is. Now it says 35 degrees over there, so it's 35 over 360. So if we plug those numbers in, it will give the area of the sector. So we've got pi times 80 squared, it's in metres, multiplied by 35 over 360. Now if we type that in on the calculator, let's see what we get. Pi times 80 squared times 35 over 360, and we get the answer 1954.7, and let's round it to 2 decimal places, 77. Obviously just be careful what the question says again, and that's metres squared. Then we can work out the area of the triangle, and obviously not forgetting, just because it's not just a triangle on its own, we can still use our half AB sine C. So we can use half AB sine C to get this one. And if we plug the numbers in, 35 there is our C. And because it's a circle sector, A and B here are the same because it's the radius of the circle. So we can do half times 80 times 80 times sine 35. There we go, and if we type all that in, 0.5 times 80 times 80 times sine 35, we get the area of that triangle there, which is 1835.44 metres squared. And then to finish that off, we can do the bigger shape, the sector, subtract the area of the triangle, so 1954.77, take away this 1835.44, and that leaves us with an overall area here. Let's work it out, 1954.77, take away answer, and we get 119.325 metres squared. And there we go, and obviously just rounding that however you'd been asked in the question. So there's quite a large selection of geometry questions there that were done on the geometry. Okay, so we're going to have a look at some statistics. This is going to be quite a short one. We've only got a few questions to have a look at, and we're going to start with a box plot. So on here we've been given some information about some time in seconds that 15 people wait to be served at a garden centre, and it wants us to draw a box plot for this part A. So we've been given a list of numbers for those minutes, and you've just got to make sure that they're in order, because we need to find a few values. We need to find the lowest value, the highest value, the median, and the 2 quartiles, the lower and upper quartile. So we can quite easily see that they are in order, so we can get the lowest and the highest value from either side, and they're going to form the ends of our box plot. So just very carefully on your scale here, drawing the ends in here, and 44, just make sure the scale goes up in ones. It does. I'm going to do it as best as I can here, and that's our 44 there. Now we need to find the median. So with 15 people, we just want to find where that halfway point is. So all you've got to do is add 1 and halve it. So 15 plus 1 is 16, divide it by 2, and that's going to be our 8th person. So we just need to go along the box plot and find where the 8th person is. So 1, 2, 3, 4, 5, 6, 7, 8. So 25 is going to be our median. That's quite nice. It's halfway between 20 and 30. Draw it in nice and neat there to form our median. Now we just need to find where the quartiles are. So on that lower half, okay, the lower part or the lower quarter here, if I try and highlight that, we've got these numbers here. And there are 7 numbers there if you just count them up. So 1, 2, 3, 4, 5, 6, 7. So again, finding the halfway point, we can do 7 plus 1 and divide it by 2, which gives us 4. So we want to find where the 4th person is for that lower quartile. So 5, 9, 11, 14. There is our lower quarter there. So marking that on the 14th person, 1, 2, 3, 4. And then looking at the higher quarter there, 27, 27, 28, 30. Okay, so once you've marked all of those on there, you've got to join up your little box. There we go, making it look like the one that you can see below, and then join up these parts here. And there's your box plot drawn. Okay, moving on to the bit below. Now I haven't added the question in here, but quite often it says to compare the box plots. So it says here, the box plot below shows the distribution of times served at a different garden centre. And it would usually say to compare them. Now there are 2 things that you want to compare when you're comparing a box plot. One of them is the median. So if we have a look, our median here is sitting on 25, and down it's sitting here on 21. Now I don't have to mention any numbers, but I would mention number 1. I would say that rows, I'll just call it rows. Rows has a higher median wait time. Okay, so a higher median wait time. Okay, make sure that you mention some context. Obviously don't just say it has a higher median. What's the story actually about? It's about the wait time at a garden centre, so rows has a higher median wait time. The next thing we have a look at is the distance between the quartiles. And again, I don't have to mention any numbers, but I just have to think, this is the distance between the quartiles. It's called the interquartile range. And on the one below, here is the distance. Now hopefully you can see there visually that on the Greens Garden Centre, there is a higher interquartile range, meaning that the data is more spread out. And you want to mention that word spread out. So number 2, my comparison here, Greens has a higher, I'm going to abbreviate it to IQR, interquartile range, meaning the data is more spread out, or meaning the wait times are more spread out. There you go, more spread out, and mention that word there, spread. There you go, so more spread out, and that is drawing a box plot and also making a comparison between the 2. Let's move on to our next one. Okay, so the next question here, we're going to draw a cumulative frequency graph. Okay, so it says cumulative frequency up here, and then it says some information about the speed of 100 lorries, which it starts to tell us over here. Now, sometimes it might give you an extra table down here to draw them in. Just take note of the fact with cumulative frequency, we are doing a cumulative total as we go up these speeds here in our groups. So we start off with 2, which is shown to us in the table just here. And then it says in the next part of the table, right here, it says, look, 0 to 40. Now that is correct. It should say 0 to 40 because that's going right from 0 all the way up to 40. And that means the accumulation or the cumulative total of 2 and 9 there. And if you add up 2 and 9, we have 11. Then there's 23. So from 0 to 60. So add the 23 into that as well. We have 34. Add the 31 into that. We get 65. Add the 27 into that, add 7 is 72, add 20 is 92, and then add the 8 into there gives us our total of 100. Now if it doesn't give you a little table to the side, you just have to do it over to the side of your table here, so 11, 34, 65, 92 and 100, and just drawing it in there instead. But sometimes it might give you the table. From there, it's quite nice and simple. We just have to actually draw it. Now, when we draw a cumulative frequency graph, we plot these numbers, these cumulative frequency numbers, against these values here, the endpoints. Okay, so depending on which table you've got, we're just going to plot it against that. So if I do this nice and as quick as I can anyway, because it's quite small, but 20 to 2 is here. Make sure it's nice and accurate. Mine's not going to be perfect. And then we've got 11, the cumulative frequency going to 40, so 11 is here. Then we have 34, and it just goes along 20 every time, so 34 is around about here. Then 65, there we go. Then we've got 92, which is here, and then finishing it up on the 100. There we go. Now when it comes to a cumulative frequency graph, it is a nice smooth curve. Just have a look what your starting number is. Now your starting number, if I highlight it, is over here. It starts on 0, so we're going to start from 0, and we're going to do a nice smooth curve, making sure you go through all the points. And there we go, there's your cumulative frequency graph. Now there's a few things that you can read off a cumulative frequency graph. The actual question that we're going to have a look at down here is find an estimate for the number of lorries with a speed of more than 90. But there's lots of things you can find. We'll start with this one. So a speed of more than 90, if we have a look, well, a speed of 90 is here. So all I have to do is very carefully go up to my graph and show this on your question, and then you go across to the left. Now this is going to vary depending on different people's curves. I'm going to try and read it as best as I can. Mine looks like it's coming out at around 84. So the answer is not 84 because it says an estimate for the number of lorries with a speed of more than 90. Well, there's 100 lorries in total, 84 up to 90 miles an hour, so it's the additional 16 on top of that, so it's 100 take away the 84 would be 16. But that's not just the only thing that you can find from a cumulative frequency graph, and if I swap to another colour, we could also find the median. So if I have a look, if there's 100 lorries, the median's going to be here, sitting on the 50th, and I could go along and I could find the median speed. Let's have a look, and then drop it down. It looks like that lands on 70 for me. So I could have a median of 70, that's something else I could have a look at. I could also have a look at the quartiles and the interquartile range again. We could find 25, I could go along from there. I could find 75, which is around about here. I could find those two values and then work out the distance between them for the interquartile range as well. So there's a lot of things that you could have a look at. Obviously you just need to make sure you draw it on the graph. And if you do the interquartile range, which is quite a good one, you go across, you find your value down here. Again, mine's not going to be perfect. It looks like about 82 or 84. Just to go for the best as I can on here, 84. If I go along for 25, that comes down, looks like at about 58 for me. So if I wanted to find the interquartile range, I could do that as well. I could do the interquartile range, and that would be 84 take away 58. There you go, and I'd work that out. What does that come out as? 26. There you go, so my interquartile range would be 26. My median down there was 70, but obviously this question was asking for the estimate there. But lots of things that you can find from a cumulative frequency graph. Next up's a histogram. This is going to be probably the fiddliest one to actually draw on here. So there's a formula that you need for histograms, because obviously on the side of this we have frequency density. So the formula for frequency density is frequency divided by class width. Okay, we'll have a little talk about that. Frequency divided by class width. Now essentially all we're really going to do here is find out what the height of each little rectangle is going to be for our histogram. Now we've already got the widths determined for us, they're in the graph here, so that one there, 60 to 65, has a width of 5. Now that frequency there is going to be the area of each bar. Now if you think about that, if we just think logically about a rectangle, if I've got a rectangle, its area is 15, the width of it is 5, what's the height going to be? The height's going to have to be 3 in order to make sure we get an area of 15 there. So essentially all we're going to do is the same thing. We're just going to do the frequency, which is the area, like in my formula here, 15, and divide it by the width, which is 5. 15 divided by 5 gives us 3. So I'm just going to do a little separate column here for frequency density, and I'm going to work out all the frequency densities. So you might just want to write down these widths over here. So this one's 5, this one's 5, this one's 10, and then this one's 20, so we do have different widths here. So 15 divided by 5 gives us a 3, which we already know the height of that rectangle is going to have to be 3. The next one is 25 divided by 5, which is a height of 5. The next one is 36 divided by the 10, so a height of 3.6. And the other one's 24 divided by 20. 24 divided by 20 is 12 over 10, it's 1.2. Again, if you've got a calculator, that's okay. Don't forget though, some of these harder ones, you could also always write that, couldn't you? You could write 24 over 20, which is 12 over 10. And that's a little bit easier then to turn into 1.2. Okay, so 1.2 for that one. You've then just got to be very, very careful. We've just got to plot this on the left. So we're going to have frequency density, so make sure you label that if it's not given to you. Our highest height there is 5. So I just want to get, as best as I can, a scale that allows me to go up to 5. So I'm just going to have a quick look because sometimes these are quite hard to see. So if I go up 10 squares for every 1 and just see if that fits. So do this in pencil to start with, just make sure your scale works. We're going to start with 0. And if I go up 5, 6, 7, 8, 9, 10 here, let's say that's 1. So then up 3, 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3. Up again, 10 is 4, and then 5 does perfectly fit there. You could do it smaller, but I'm going to try and give myself as much space as possible, so making sure we've got the labels here. Then we just need to draw these in. They're quite simple to draw once you've got this information. So if we draw this in, look, just making sure you get the widths right. That first speed there is 60 to 65, so my width is going to be 5, so it's only going to be this wide here. Let's have a look, is that enough? 1, 2, 3, 4, another square along 5, and that's going to go up to 3. Ooh, not very well drawn there, obviously using a ruler and a pencil, so there's your first bar. The next one has a height of 5, and again, and it has a width of 5, it goes from 65 to 70. So continuing that line up, we can go up to 5. I'll do this as best as I can, there we go, there's the next one. The next one has a height of 3.6, so being super accurate here, and a width of 10, it goes along to 80. So if I find 3.6 as best as I can, 1, 2, 3, 4, 5, 6. There we go, and then drawing that bar in, and then the final bar there has a width of 20 all the way up to 100 and a height of 1.2. So 1 is there, 0.2 just about as best as I can, and there is your histogram. Okay, so we can also look at some stuff from this as well. So the question here, which I'm going to have a look at, this part B, says work out an estimate for the number of cars with a speed more than 85. Now you can actually do this from the table, or you could do it from your graph. Now 85 is, if we have a look on the graph, 1, 2, 3, 4, 5, it's halfway between 80 and 90 there. Now this bar here, we've already determined is 24 people, or 24 lorries. Now if you think about this, 5 along, actually that could split up into 4 equal chunks that big. Okay, it's a quarter of the way along, and a quarter of 24, 24 divided by 4, is 6. So in each of these little chunks we could estimate that there's 6 in each. Obviously we don't know because it is group data, but we could estimate that there's 6 in each. So if we work out an estimate for a number of cars with a speed of more than 85, well it'd be these little 3 chunks of 6 here, and 6 plus 6 plus 6 would give us 18. And that'd be a good little estimate for us there. We could also do it from the numbers though up in the table, because if it's a quarter of the way along, we know it's 3/4 of this little group, and 3, we could have just done 3/4 of 24. 3/4 of 24 is 18, divided by 4 is 6, times it by 3 is 18. So you can do little readings from your histogram like that as well. Let's have a look at our next one. Okay, so the last one here, we're going to have a look at a reverse mean question. Now I know it's a reverse mean when it starts to talk about actual means. It says that the mean for certain people is, and then starts to give us some information. So it says there are 20 men, 20 women and 10 children, and they take part in a quiz. And then it gives us the mean score for the men, the mean for the children, and the mean for the whole group. And it wants us to work out the mean score for the women. So that's what we want to work out eventually. So all we got to do is think in reverse for this. So when you're working out the mean, you get the total and you divide by how many people there are. So if we think about the men, you don't have to write it like this, but just so you have an understanding of this, you would get the total, which we don't know, you divide it by the 20 men, and it says it gives us an answer of 6, the mean for the men. So if we reverse this round, times both sides by 20, so times by 20 gives us a score of 120 for the men. So that's the total score for the men. We could then do exactly the same for the children. I don't have to write out this little bit of algebra every time, but if I just think, okay, well the children then, I just know I need to times the amount of children by the mean. The mean is 4, and there are 10 children. So 10 times 4 gives us a total score of 40 for the children. There we go. Now we don't actually know what the mean is for the women, that's what we're trying to work out, but what we are given is this last bit of information here, which says the mean for all of them is 5. Now in total, if we have a look at the question, it says there are 20 men, 20 women and 10 children. So that's 50 people with a mean of 5. So that we could do 50 people times the mean, which is 5, which gives us a total score of 250. So that's our total there. So now we know the total score, we know the score for the men, we know the score for the children, so we can actually work out what score the women got. So if we do this to the side, we know we have to do 250, take away the 120 that the men got and take away the 40 that the children got. And if we work that out, 250 take away 120 is 130, take away the 40 leaves us with a total score of 90 for the women. So the women scored a total of 90, and it says that there are 20 women. So to work out the mean for them, we've got 90 is their total score divided by 20. And again, depends whether you have a calculator or not here, but even if you don't have a calculator, we can do this one. We can cancel off the 0 top and bottom, and it's 9 over 2, or 9 divided by 2, which is 4.5. There we go. So the women have a mean of 4.5, and that'll be our final answer there to finish that off. There we go, and that's our little bit of statistics done. Okay, and looking at some ratio and proportion now. So this says James has a bag full of counters. He takes at random a sample of 20 counters, marks them all and puts them back into the bag, and then he takes 30 counters at random, and out of the 35 of them are marked. Estimate how many counters are in the bag. So we're looking at capture, recapture here. Now if we just make a few statements, because we're going to assume that the sample is proportional to the next one that he took as well, or to the rest of the counters in the bag. So initially, he takes a sample of 20 counters out of we don't know. That's what we're trying to work out, so let's call that 20 over x. On the next time, he takes a sample of 30 and 5 of them are marked. So we'll say that that's now 5 out of 30. So out of the 35 were marked, but previously it was 20 that were marked out of something we don't know. But we are going to assume that these are proportional. So in order to work out how many that x value is, we just have to think, okay, well, how do we get from 5 to 20? And we do that if these fractions are equivalent by multiplying by 4. So in order to get that number on the bottom there, we would multiply this by 4, and that would give us 120. So our answer would be 120 counters. Okay, obviously we are making some assumptions here. We are assuming that no additional counters were added to the bag in between the two samples, and also none were taken out as well. And obviously there's little silly things like we're assuming that the marks haven't actually come off the counters or anything like that in this time frame. Okay, so that is capture, recapture there. Okay, on to some direct and inverse proportion. So there's two formulas that we can use here. It says A is inversely proportional to B. So it's either going to be A equals K lots of B, or A equals KB, or it's going to be A equals K over B. So these are the two that you have to remember. Now with inverse proportion, it's this one here, where K is being divided by B. So we're going to use that formula, so just make sure you write them down straight away. And then it gives us some values to put in. So it says 15 for A, so 15 equals K over, and it says B is 4. So we can solve this for K. We can times both sides by 4 to isolate K there, and we get 60 equals K, or K equals 60. And now what we can do is we can put that 60 back into the original formula here, and that will give us our formula. So A equals 60 over B. And that is a formula for A in terms of B, and sometimes you might just be asked just to write a formula for A in terms of B, and there it is. But this question says find the value of A when B equals 12. So all I've got to do is stick B equals 12 into my formula down here. So if we do that, I'm going to do it to the side, we get A equals 60 over 12, and 60 divided by 12 equals 5. So our final answer there is 5. So every time you just think which formula am I going to use, plug your pieces in, find your value of K, and then reuse that in your formula for whatever values you need. Okay, so this question says directly proportional to. So we're going to be using the other formula this time. It's A equals KB. But you've got to read the question carefully, because this one says directly proportional to the square root of B. So I need to put a square root in with my B. So using the same formula, but just putting my square root in. Remember, it could say squared or cube rooted or anything. But that's my formula I'm going to use. Then it says when A is 18, B equals 16. So if we put those values in, A is 18, so 18 equals K, and I'm going to put a times sign in here, the square root of 16, and you can do that in your head hopefully. The square root of 16 is 4. So I'm just going to put K times 4. Now again, we can actually find the value of K here. We can divide both sides by 4. So if I divide both sides by 4, we get a decimal here because it's 18 over 4. So 18 over 4 equals K. Now if we simplify that down, let's have a look. Divide top and bottom by 2, we get 9 over 2. Which we can either leave as that or we can turn into 4.5. I might just leave it as 9 over 2 for the moment, see where we end up with this. But we've got our value of K. So if we put that back into our formula now, so just putting that back up here for our value of K, we get A equals 9 over 2 root B. There we go. And there is our formula for a in terms of b. A is 9 over 2, or 4.5 times root b. And then it says find the value of b when a equals 2. So if we put those into our formula there, a equals 2, so 2 equals 9 over 2 root b. There we go. Right, so we need to rearrange this. So I need to divide both sides by 9 over 2 or divide both sides by 4.5. If we've got a calculator, that's fine. If we don't know, we can just do 2 divided by 9 over 2. Remember, in fraction rules, that would be 2 over 1, and you would times it by the flipped version, 2 over 9. And that would give us 4 over 9. So 4 over 9 equals root b, and if you've got a calculator you can just type that straight in. So 4 over 9 equals root b. In order to find out what b is, we just need to square both sides, and when you square both sides there, 4 squared is 16, 9 squared is 81, there we go, and we get 16 over 81, so our final answer there is a fraction. There we go, just following those normal fraction rules there. That would have been absolutely fine with a calculator, but just a different way to approach this if it is non-calculator. Okay, so we've got one of these questions with lots of ratios going on. It says in a bag of shapes are either circles or squares, and then they're white or black, and gives us some ratios about them. And it wants us to work out what fraction of all the shapes are white. Now if I start to break this information down a bit, it says fraction, so I'm going to just start to turn these into fractions. Now it says we've got circles and squares, and that's in the ratio 3 to 5. So in total that's 8, so we've got 3/8 that are circles, and 5/8 that are squares. And then it gives us some information, so it says the ratio of black circles to white circles is 5 to 7. So if we have a look at this, we've got black and white, and that is 5 out of 12, 5 plus 7, and 7 out of 12 for the white ones, okay? And then it goes on to the squares, so we've got 1 to 3, and again that's black to white. 1 to 3, so it's 1/4 and 3/4. Now if I treat this just like a probability tree, because it asks me for the total fraction, so if I think, well, what's the probability of picking a white, a white shape? So if we have a look at the circles, we can go through the 3/8 and down the white shapes there to 7/12. So just like on a probability tree, we would do 3/8 and multiply it by 7/12, and that's going to tell me the fraction of circles that are white. I can do the same with the squares, so 5/8 multiplied by that one there, 3/4. So 5/8 multiplied by 3/4, and that's going to tell me the fraction of squares that are white. Now if we work these out, times in fractions is nice and easy. So times in the top, let's just move this to the side a little bit. So times in the top there, we would get 21 over 96. Times in these on the right, we would get 15 over 8 times 4, which is 32. And there's our two fractions. Now just like with probability here, we just need to add these two together, which means we need a common denominator. So not very nice, but you might have spotted here that this fraction simplifies. And if we divide the top and bottom by 3, 21 divided by 3 is 7, and 96 divided by 3 is 32. So actually we can now add these two fractions together. We've got 7 over 32 here and 15 over 32 here. And if we just add those together to finish that off, now that there's a common denominator, 7 over 32 add 15 over 32 gives us a final answer of 22 over 32. And again, you could even simplify your answer there if you want. It doesn't say to, but if we halve both of them, because they both divide by 2, we get 11 over 16. So completely up to you there. We've got two different answers, 22 over 32 or 11 over 16 would be a fine answer there. But obviously in that scenario it's quite nice because one simplified to make a common denominator. If not, you just have to apply your normal fraction rules there to get your common denominator. On to some equivalent ratios here. So when ratios are equivalent, if we think about this logical idea here, 1 to 2 is also equivalent to 2 over 4. Now we can apply a little trick here, because if that is true there, we can also make the statement that 1 over 2, the left over the right, is equal to 2 over 4. And we know that that's correct, isn't it? 1/2 is equal to 2/4. And I'm going to apply that same trick to this question here. Even though we're involving some algebra now, we've got 3x plus 5, that's not a 3, we've got 3x plus 5 in the first one. So 3x plus 5 over the second one there, x plus 4, is equal to the first one, 2x plus 4, over x plus 2. And there we go. Now we've actually got an equation that we can solve. So this is more of an algebra question, but it's a trick with the algebra there. With the ratio. So what we can do, and we've got two fractions either side, we can cross multiply. So I'm going to times the x plus 4 up to this side and times the x plus 2 up to the top of this one. So we get a double bracket. We get 3x plus 5 multiplied by that right denominator, x plus 2. And that is equal to 2x plus 4, what's on the top of there, multiplied by that left denominator, which is x plus 4. So all we need to do now is expand both these brackets out. I'm going to do this in quite a quick step. So the first one, we get 3x squared plus 11x plus 10. And on the right one here, we get 2x squared plus 12x plus 16. So we've got quadratics here and we just need to make it equal 0. I'm going to do this in quite a quick step. I'm going to move everything here on the left hand side to the other side. So I'm going to minus 2x squared, minus 12x and minus 16, and that's now going to equal 0. So 3x squared minus 2x squared leaves us with x squared. 11x take away 12x leaves us with 1x, so minus 1x, and 10 take away 16 is minus 6, and that now equals 0, and then we can solve it. So all I did was minus 2x squared minus 12x and minus 16 from both sides, so that equals 0. Now we can solve it. So looking at this now, I just need to factorise it. So the factors of 1 and 6 are either 1 and 6 or 2 and 3, and it's going to be 3 in the middle there, so it'd be x plus 2 and x minus 3, and that would give us minus 1 in the middle, and that's what equals 0. So we've got two solutions here, which is why it says find the possible values of x. We've got this solution here. You got x could equal minus 2, and you got the one to the right of that as well. You got x could equal 3. So there's your two solutions, x equals 2 and x equals 3. Finish that off. Last question here, we've got a speed time graph, very similar to a velocity time graph as well, similar process in what we do. So part A says find an estimate for the distance travelled in the first 10 seconds. We know that our formula, speed is distance over time. So actually working out distance is speed times time, which just means all we have to do is work out the area underneath the graph. So normally it would say to split this into equal widths. Okay, I haven't actually added it to this one, but we're going to split it into 5 equal widths. So along the bottom, along the time, it goes up to 10. So each bar I'm going to draw in, I'm going to split it at 2. So every 2 seconds, I'm going to split the shape up and draw it in. Here we go. And I'm going to connect those up together here to make the shape. So I've got a triangle there, a trapezium, another trapezium, another trapezium, and a final trapezium there. Now this is going to be quite awkward for me to do on here, but I'm going to give it my best shot. So the height of this triangle, I'm going to write them all in because the base of all these shapes is 2, but I just need to work out the area of all these shapes. So the height of the triangle there, as best as I can see, looks like 27. So the height of that is 27. The height of the next trapezium, as best as I can, is 44. You just need to be super accurate with these. The height of the next one is 50. The height of this next one here is what looks like 44 again to me. And this final height at the end here is 20. So what I need to do is work out the area of them all. So I'm going to label these up 1, 2, 3, 4 and 5 and work out the area of all these shapes. So shape number 1's a triangle. So base times height, 2 times 27 and halve it is 27. So just having a look at the units here, it's metres per second. So the shape 1 is representing 27 metres. Shape 2, we've got the area of a trapezium here. Don't forget the area of a trapezium formula, which is add together the parallel sides, or a plus b, divide it by 2, and then times it by the height, which in this case is the distance between them. Now it's really nice when you've got a distance of 2 between them, because actually dividing by 2 and times by 2 cancel each other out. So actually you just have to add up those two parallel sides. So for number 2, 27 add 44 is going to give us 71 metres. Again, plug it into this formula if it doesn't have a width of 2. Number 3 is going to give us 94, 44 plus 50, so 94 metres. Number 4, 50 plus, number 4 is the same again, 94 metres again. And then number 5 is 44 plus 20, so 64 metres. So all we need to do is add them all up, which I'm going to do on the calculator. So adding all of those up, we've got 27 plus 71 plus 94 plus 94 plus 64, and that gives us a total distance there of 350 metres. Right, there we go, just adding them all up. Let's put that down the bottom there, 350.
Okay, so one more thing that we could have a look at on here, and it's part B. It says work out an estimate for the acceleration at 2 seconds. Now this is a bit awkward to do on the same graph, but what I'm going to do is I'm just going to get rid of some of the drawings here around the 2 second mark. Now in order to get an estimation for the acceleration, we've got to draw a tangent at this point here, and that can be awkward. I've obviously just gone up from 2 there to find out where that is. So you just got to get your ruler really carefully and make sure that it just touches at that point and then skims off. Now it's very hard for me to do on the screen here, but that's it, drawing a tangent there. And then all you need to do is draw a little triangle underneath or above and work out the rise over the run, or the change in y over change in x. Okay, so if I just draw this in, and a little tip if it's a non-calculator is to try and get that change in x to be 1. So I'm just going to have a look to see if I can actually do that. So if I go from here, I go across 1, 2, 3, 4, 5 squares, that's a change in x of 1. And I get that distance there, which for me actually perfectly goes to 10. So it's going to be different on the paper because it's quite hard to do it on here, but that gives me a 1 and a 10. And obviously to work out the gradient, you do the change in y over the change in x, and mine comes out as change in y is 10 and the change in x is 1, and it's sloping upwards, so it is positive, and that gives me a gradient of 10. So in terms of an acceleration here, my acceleration would be 10 meters per second squared. And that's your units for acceleration there. So 10 meters per second squared is my acceleration. Right, and that's the end of ratio and proportion. Okay, so moving on to probability. So we've got here, Emma has a bag of shapes, and in the bag there are 8 red cubes, 7 red spheres, 5 blue cubes and 12 blue spheres. Emma's going to take 2 shapes out of the bag, and she's only allowed 1 sphere, 1 cube, 1 red shape and 1 blue shape. How many different ways can she select them? So we're looking at the product rule for counting here in combinations. So all we have to do is think about here, how many options does she have on the first pick, and we're going to multiply it by the amount of options on the second pick. Problem is we've got this scenario here where she's only allowed 1 of each shape and 1 of each colour. So if we think about this at first, if she takes a red cube, then she can't take another red shape, so she can't take any of those red spheres, and she also can't take any of the blue cubes because she's only allowed 1 red shape and 1 cube. So if she takes a red cube, the only other option on the next pick is to take a blue sphere. So for that first option there, she has 8 on the first pick out of the red cubes, multiplied by 12 of the blue spheres. So 8 times 12 would give us the amount of combinations there that she can get for the first pick, and that's going to be 96. So she could take that combination there of red cube and a blue sphere. Now alternatively, she could also take, on the first pick, she could take a red sphere, and that would mean on the next pick she can only take a blue cube to enable her to only have 1 of each shape and 1 of each colour. So that would give her a total amount of combinations there of 7 on the first pick there if we took a red sphere, multiplied by 5 of the blue cubes, and that would be a total of 35. So she has 2 different ways of picking these shapes. We've got 96 options on the first and 35 on the second. So if we add all these different options together, 96 plus 35 would give us a total amount of combinations here of 131 to meet that criteria of only having 1 shape and 1 of the colours for each one there. So 1 sphere, 1 cube, 1 red shape and 1 blue shape, and that's combinations there. You just got to remember how many choices are there on the first pick, and you multiply it by however many choices there are on the second pick, and then combine any if there are multiple different ways. Okay, so the next one, we've got a lot of information here. So it says Sophia asked 50 people which drinks they like best, from tea, coffee and milk, and all 50 people that she asked liked at least one of the drinks. Then it starts to talk about all these different ideas about what drinks people liked and whether they liked all 3, whether they liked tea and coffee. So we're going to go through all of them there, but ultimately it says she selects at random one of the 50 people, work out the probability that this person likes tea. So we need to figure out from all this information how many of the people there like tea, and it doesn't explicitly tell us how many like tea. So when we've got these 3 options like this, the best way for us to organise this is in a Venn diagram, and specifically a 3-way Venn diagram. So we need to draw, I'll do this as best as I can, a Venn diagram that's going to allow us to have 3 elements in there, and you just need to make sure with a Venn diagram you draw your little box around the outside. There we go. Now I want to keep this all nice and neat and tidy, so I'm going to label them. I'm going to call this one the milk, this one the tea, and this one down here, the coffee. I'm just going to go through the list and just start to tick things in when I know that I've got them there. Now the first piece of information it tells us, and if we go through this step by step, it says all 50 people like at least one drink. So that means we know that there's going to be nobody in the outside, so 0 on the outside. Next thing we've got is 19 people like all 3 drinks, and that's a key piece of information there because we can definitely put that in straight away. The people that like the all 3 are right smack bang in the middle there, so we've got 19 in the middle. So we've dealt with that one, and you can tick them off as you go or highlight them. So that next one says, it says 16 people, I'm going to swap to a different colour here, it says 16 people like tea and coffee but don't like milk. So the people that like tea and coffee are going to be in the crossover between the T and the C circles, but they do not like milk, so that's fine, we can put them in there, 16 that like tea and coffee but do not like milk. There we go, tea and coffee but don't like milk. It then says 21 people, let's try swap to another colour, 21 people like coffee and milk. Oh, I'm just going to get rid of that because I've got too many things going in there. I've got 21 people like coffee and milk. So 21 people that like coffee and milk, well let's have a look. Coffee and milk is this crossover here, but also includes that 19. It doesn't say 21 people like coffee and milk but don't like tea. So if 21 people like coffee and milk, well, we've already got 19 in there that like coffee and milk, so that's going to be an extra 2 that makes that up to 21 there in that little crossover with coffee and milk. 19 of them also like tea, but then 21 in total like coffee and milk. So that's that one dealt with. How many have we done now? We've done all 4 of those. There's lots on here. On to the next one. We've got 24 people like tea and milk. So 24 people like tea and milk. Let's have a look. Well, tea and milk is this one here. But again, it doesn't say that they don't like coffee. So 24 people like tea and milk. 19 are already in there. So that's going to be an additional 5 people there. And that makes up 19 and 5. That's 24 people in total that like tea and milk. On to the next one. We've got 40 people that like coffee. Well, we've already got 3 people in our coffee circle there. We've got the 2, we've got the 19, and we've got the 16. So in total, that adds up to, let's have a look, 2 plus 19 is 21, add the 16 is 37, and it says 40 people like coffee, so that's going to be an extra 3 that make that coffee circle up to 40. Next one, this one's a nice easy one to finish. We've got 1 person likes only milk. So in the milk, we've got 1 person, and then we're given no more information. But there is this missing number here in the T. Now just remember, it did say in the question that she has 50 people. So if we add up all the numbers we've got 1 plus 5 plus 2 plus 19 plus 16 plus 3. And all of that adds up to make 46. And in total, we have to have 50 people in our Venn diagram. So just in the T one there, that's an additional 4 people to make sure that we have 50. So we just did 50, take away 46, which left us with those remaining 4 people. So we filled in our Venn diagram. Now it says Sophia selects at random one of the 50 people, work out the probability that this person likes tea. Well, that doesn't say just likes tea, it says the probability that they like tea. So we've got a few of the numbers here that we can actually consider. We've got the 4, the 5, the 19 and the 16. So the amount of people that like tea, if we add them all together, 5 plus 4 is 9, plus the 19 is 28, plus the 16, what does that give us? 19 plus 16 plus 5 plus 4 gives us a total of 44 people that like tea. So there's 44 people that like tea out of a total of 50 people, so it's 44 out of 50. 44 of those 50 people like tea, and the rest don't like tea. You've got the 1 person that only likes milk, you've got the 2 people that like milk and coffee, and the 3 people that only like coffee. So 44 over 50, and you don't need to simplify that. And that's our Venn diagram done. Just make sure you go through and tick them all off as you go so you haven't missed any. Let's have a look at another one of these. Okay, so this Venn diagram is a little bit more complicated. It says 82 students were asked what their favourite fruits were. 39 like apples, 50 like bananas, 39 for oranges, 21 like apple and bananas, 18 like bananas and oranges. And we've got some more information there, but the one we're looking for is the amount of people that like all of them, and this doesn't actually tell us the amount of people that like all of them. So we're going to have to take a little bit of a different approach here, but it does say how many of the students like apples and oranges but not bananas, so we're going to look for those people in a sec. Now if I draw a little Venn diagram for this one again, I'm going to need a little bit more space. I might actually make that a little bit bigger. Let's make this one a bit bigger. Okay, so we've got our Venn diagram, again, nice little box around the outside, and let's have a look at what needs to go in here. So 82 students were asked what their favourite fruits were. So we know that 82 people are going to have to go into our Venn diagram. Now it says that we've got lots of different bits of information, haven't we, here? So let's just label it up so we can keep it nice and clear. Apples, bananas, and oranges down here. Not to mistake that for 0 people there, that's oranges. Now we don't know how many people are in the middle, so we're going to apply a little bit of algebra here. I'm going to say, okay, well, there is an amount of people in the middle, and we'll call that x. Now we can start to have a look at some of the other bits of information. I'm going to disregard the apples, bananas and oranges bit to start with, but what I am going to do is just label that up here just so I remember. So apples is 39, so we know 39 in total in that circle. Bananas is 50, so we know there's a total of 50 going into that circle. And oranges is 39, so we know there's a total of 39 going into the oranges there. Okay, so I'm going to tick those all off. I've drawn them on my Venn diagram, I'll remember that later. Now it says, there we go, 21 liked apples and bananas. So 21 like apples and bananas. So that is going to be 21 in total, including that crossover that's going in these two, just here where the apples and bananas cross over. So if I knew what the middle number was there, I'd do 21, I'd take away the value of x in the middle, but I don't actually know what x is, so I'm just going to write in here that's 21 minus x for that one. Okay, so that's that one done for the moment in terms of algebra. Then we've got 18 that like bananas and oranges. So bananas and oranges is just here. But again, we don't know what that middle one is there. It doesn't say that they like bananas and oranges, but not apples. So that's going to be 18, take away the middle number, which again is x, 18 minus x. Onto that last one, we've done this one now. So 19 liked apples and oranges, and again that's this one here, apples and oranges, but again we don't know the middle number, so we'll call that 19 minus x. There we go. So there's our bits of algebra. Let's tick that off. And then it says 22 like exactly 2 of the fruits. Now the people that liked exactly 2 of the fruits are the first one we did, 21 minus x that like apples and bananas. We've got 18 minus x that like bananas and oranges, and we've got 19 minus x that like apples and oranges. So what we can actually do is we can create a bit of an equation here. Now if we add those all together, that has to equal 22, because it says 22 here liked exactly 2 of the fruits. So if we add them all up, let's have a look, let's just add them all up. We've got 21 minus x, we've got 19 minus x, and we've got 18 minus x. And if we add them all together, let's see what we get. So 18 plus 19 plus 21 gives us a total of 58. So we have 58 minus 3x's, so minus 3x. So actually we can create a bit of an equation here. I'm running out of space a little bit, so I'm going to do it over here. But we have this equation, we've got 58 minus 3x, and it says it has to equal 22 people. So actually we can just go about solving this now. So actually what I can do, and we can rearrange it if we like, but I'm just going to minus 58 from both sides. So 22 minus 58 gives us negative 36. So we have negative 3x equals negative 36. And if we do negative 36 and divide it by negative 3, that gives us a value of x, which is 12. So we know that x, that one in the middle now, has to be 12. So actually what we can do, we can start to get rid of some of these numbers and actually, get rid of some of these x's and replace them with numbers. So if I get rid of the x in the middle, and we'll replace that with the 12, because we now know that 12 is in the middle. We can then do 21 minus x above that, which leaves us with 9. So we can get rid of 21 minus x. Oh dear, got rid of the whole circle there. We can get rid of 21 minus x, and we can just put 21 minus 12, which is 9. So there's 9 going in there. We can get rid of 19 minus x. 19 minus 12 leave us with 7. So we can get rid of that. We just got 7 in there. And then we've got 18 minus x on the right there, and 18 minus 12 leaves us with 6. So we can have 6 in there. There we go, 6. Now we might be able to answer the question from here, but let's go ahead and fill in the rest of the Venn diagram as well. So we know that in A, there's 39 in total, and we've got 9, 12 and 7 that's already in there, and 9 plus 12 plus 7 is 28. So we need an extra 11 in the apples there to make it up to 39. Moving on to the bananas, again we've got 9, 12 and 6, and 9 plus 12 plus 6 is 27. We want to get to 50, so that's an extra 23. And then in the bottom one, we've got 7 plus 12 plus 6, adding up to 25. We need 39 in there down the bottom, so that's going to be an additional 14. Right, there we go. So that's our Venn diagram filled in.
Now the question said, not to forget what it was actually asking us here, it said how many of the students like apples and oranges but not bananas? Now the ones that like apples and oranges but not bananas are here. Let's highlight it. These ones here like apples and oranges, but they don't like bananas. So we've got 7 people there. So we've got a total of 7 people out of the 82 people in total, and that would be our final answer. There we go. So you can apply this to a Venn diagram that's not a triple Venn diagram where you've just got a normal two circle Venn diagram as well, but when it doesn't give you that crossover number there, you do have to think about how you can apply algebra to this. So that's quite a complicated one there, but just a little example of how you can approach some of these harder Venn diagram questions. Okay, and on some probability here, it says there are 5 red pens, 3 blue pens and 2 green pens in a box. Leah takes at random a pen from the box and gives the pen to a friend. Leah then takes at random another pen from the box. Work out the probability that both pens are the same colour. So we can do this using a probability tree, but there are 3 things. So I'm going to have 3 branches here, and it can get quite messy. So we've got red, we've got blue, and we've got green. Now in total there we've got 5 red pens, 3 blue pens and 2 green pens, and in total that adds up to 10 pens. So this is going to be all out of 10 pens here. So the probability of getting a red is 5 out of 10. The probability of getting a blue is 3 out of 10. And the probability of getting a green is 2 out of 10. Now it's up to you. We can do all 3 branches coming off these if you want for that second pick. It says she doesn't replace it. So off each branch you've got red, blue, green, red, blue, green, and red, blue, green for the bottom. But really, we're only really concerned here about the same colour. So I want to know what's the probability of red on the second pick if we take a red, what's the probability of blue here if we take a blue, and what's the probability of green down here if we take a green. Now if we think about this, there are 5 red pens in the box. So if we were to take another red pen, that would reduce down to 4, so there would only be 4 red pens left, and now there'd only be 9 in the box. So I don't need to fill in every branch on the tree here. We've still got 3 out of 9 for blue, and we'd still have 2 out of 9 there for green, but I only really care about the probability of getting another red at this point. Moving on to the blue branch, so down here, we have 3 blue pens in the box, so if we take one out, we've now only got 2 blue pens, and again, that's going to be out of 9. So that's the probability of getting a blue if we took a blue on the first pick. And then the final scenario down here, if we took a green on the first pick, we'd only have 1 green left, and again there'd only be 9 in the box, so that'd be 1 out of 9. So there's the probability of getting this second colour when it's the same. So just like normal probability trees, we just need to work out these 3 probabilities here. So for the first one, we'd do 5 over 10 multiplied by 4 over 9, which is nice and easy for us to do, times the top is 20, times the bottom's 90. Into the middle, we've got 3 over 10 multiplied by 2 over 9, and again that's going to be over 90, but with 3 times 2 on the top, which is 6, and 90 on the bottom again. And then the final one, we've got 2 over 10 multiplied by 1 over 9, and 1 times 2 is 2, and again 90 on the bottom. So there's our 3 probabilities. We've got the probability of getting red, red of 20 over 90, blue, blue would be 6 over 90, and green, green would be 2 over 90. So when we want to combine all of these together, all we have to do is add them all up. So add all of these together to get our total probability. Let's just put some plus signs here. And 20 on the top, plus 6 is 26, plus 2 is 28. So our final probability there would be 28 out of 90. And again, you don't need to simplify that. So that'd be your final probability. There you go, a little bit of a trick there. When you are constructing these trees, if you only need certain branches, then you can just kind of ignore the others, but just be very careful what the question's asking for, because it could have asked us for different colours there. Just on a side note, if it did ask us for different colours, that would have obviously been the other 6 branches, but you can also save your time just working out the 3 that we don't need, and then we could take that numerator there, 28, away from 90. So the probability of different colours would be 62 over 90. What's left over there, different colours. Okay, that would be only though if it said different colours, and this particular question did say the same colours, so just be careful, but you could save yourself a bit of time. Rather than working out all 6, you could just work out these 3 and take it away from 90 for your numerator. On to the final question here on probability trees. It says there are 4 red counters and X blue counters in a bag. 2 counters are removed from the bag, and the probability that both the counters are taken is blue is 1/3. Work out the value of X. Now, the tree here isn't so nasty to construct, but we have got some algebra going on in the tree. Now, what it says is there are 4 red and X blue. Now, so for the total amount of counters here, we don't actually know what the total is, but we could write it in terms of algebra. If we knew the amount of blues, we'd just add it to the amount of reds, so we could say it's X plus 4 is our total, and that's going to be our denominator on our tree here. So if we just construct 2 branches for our tree, we've got red and we've got blue, and the probability for red there is going to be 4 out of X plus 4, and the probability for blue is going to be X over X plus 4. Now again, really, the only part of the tree here we're actually considered, we want to consider is the probability for both of them being blue, because it says the probability that both counters are blue is 1/3. So I don't really need to do the whole tree here, I just need to have a look at this probability down here, and that would be if I took a blue on the second pick. But again, I'm actually just going to go and construct all the branches here so that we can just discuss them, but we only actually need the one at the bottom. Now, if we took a red, that would reduce our amount of reds down to 3, because there are 4 reds in there at the moment. So if I imagine that we've taken a red out, we would only have 3, and that would no longer be over X plus 4, because one of them's gone, so it would be over X plus 3, reducing that denominator by 1 again. Onto the blue branch. If we take one of the reds out, obviously none of the blues have actually gone, so we've still got X blues, but that is going to be over X plus 3. Again, all the denominators are the same. Onto the bottom half of the tree, if we took a blue out on this bottom half, the amount of reds would be the same, so we would have 4, still over X plus 3, because we've lost one on the bottom, and the one that we're really concerned about here is this bottom one, which is if we took a blue out. Now, we don't know how many blues there are, so we'd have to just say, okay, well, that'd be X minus 1 counter over X plus 4, and that's how we can construct a probability tree using algebra here. Now what it says is, it says that those probabilities down here, so the probability of getting a blue and then getting another blue is 1/3. So when you times these fractions together, it says they're going to equal 1/3. So if I try and get rid of a lot of this tree here, because we're only really concerned about these bottom ones, let's have a look at what we're left with. So these are our branches. So we can actually do the working out for this. Now what we're saying is X over X plus 4, the first probability, multiplied by X minus 1 over X plus, I just realised I put plus 4 down there, that should be a plus 3. Oh dear, let's change that. X plus 3, there we go, because we took one of the counters out. So X minus 1 over X plus 3, and it says that all of that equals 1/3. Obviously I've got limited space here, so I'm going to get rid of that tree now that we've corrected that denominator, and we've just got to actually work out all of this algebra here, and we've got a bit of an equation. So if we go about working this out now, if we multiply these fractions together, multiplying the numerators, x times x minus 1 gives us x squared minus x, and if we multiply the bottoms there, we have a double bracket to work out. Okay, so you can imagine these are in a double bracket. That first one was like a little single bracket, x times x minus 1. So if we multiply out the double bracket here, we get x squared plus 4x plus 3x, which is plus 7x, and 4 times 3 is 12, so plus 12, and it says that equals 1/3. Okay, so from here, we've got to cross multiply to get rid of these two denominators, so I'm going to times the denominator over here up to the 1, and the 3 up to the other side there, so timesing both sides by 3 and timesing both sides by this quadratic on the bottom, the x squared plus 7x plus 12. So if we do that, I'll write this out as like a step you can see to start with. We'd have 3 lots of x squared minus x equals 1 lot of, so I won't write this in a bracket, but 1 lot of x squared plus 7x plus 12. And now we can actually go about solving this. So obviously we need to expand this bracket out to start with, so by times these both by 3, and we get 3x squared minus 3x equals x squared plus 7x plus 12. Now, just like with all quadratics, we need to make this equal 0. So I'm going to move everything to the left-hand side. So I'm going to subtract all 3 of these pieces. I'm going to subtract x squared, which would leave us with 2x squared when we take x squared from both sides. I'm going to take away 7x from both sides, which would leave us with negative 10x over here. And I'm going to take away 12 from both sides. We haven't got a number on the left, so it's just going to be take away 12 there. And now it equals 0. Now we can actually go about solving this, so we can either factorise or use the quadratic formula. This one I think does actually factorise, but we can simplify it first. We can divide everything by 2. So if we divide everything by 2, we get x squared minus 5x minus 6, which equals 0. and now it's quite nice and easy for us to factorise there. So I'm going to bring this up to the top, I'm going to factorise it out of the way up here. So factors of 6 are 1 and 6, or 2 and 3. So this actually factorises, let's do it up here, open up our brackets, and we want -5 in the middle, plus and -6 at the end. So the only option in there is going to be -6 and +1. That would allow us to get -5, so we'd have x minus 6 and x plus 1. There we go, we've factorised it, so we've got our two solutions there. So obviously you flip the sign, so x is 6, and for here x equals -1. So what does this mean in terms of the question? Now it said work out the value of x. This is what we've been doing here, working out the value of x. And x there is the amount of blue counters. Now there can't be -1 blue counters, can there? But there can be 6 blue counters. So it has to be the positive value there. X would have to equal 6 as our final answer, because we can't have -1 blue counters. So just something to be thinking about there. Right, there we go. And that's the end of probability.
Right, well done for making it to the end of the video. Here are all the topics that you've covered coming up. Make sure that you do some further revision on some of these topics, if any of them were ones that you've highlighted as things that you need to have a further look at. But well done getting to the end. There's got a lot of content there. Hopefully it's a really good help for you pre-exams to cover off all these topics if you are aiming for those higher grades. But again, do your own subject analysis. Make sure that you have a look through your revision guide. Just don't forget, if this was useful, please do like the video, please share it with your friends, and obviously subscribe to the channel, and don't forget to follow me on Instagram and on Twitter as well.